Okay, so settle down, please. Good morning, dear. Good morning to everyone. अगर कोई बच गया हो उसको भी. Okay, so we start with the. I think yesterday we did all the 4 types of fronts. This was clear to all of us. Any major doubt? 4 type of front clear है? Okay, very good. Or the 2 types of cyclone that we get at the 2 fronts, that is also clear. Which are the 2 types of cyclones? हाँ, थोड़ा जल्दी जल्दी बता दो यार. In the warm and cold front, and the difference between the two, which is formed generally on the eastern side of the low pressure? Warm front, right? And they catch up, and finally once they catch up, they lead to occlusion. That is also clear. And at the time of occlusion, what type of temperature condition will be there vertically? Vertical temperature condition क्या है? As you go higher, the temperature. Yes, so it creates a temperature inversion type of situation. This is something that we did not write yesterday. वो लिख लीजिए. That when occlusion will take place, it also leads to. When occlusion takes place, it also leads to temperature inversion type of situation. Okay, it also leads to temperature inversion type of situation. Come again? हाँ, तो ये फ्रंटल इन्वर्जन हो गया आपका. ठीक है, आई होप यू रिमेम्बर, हमने किया था वहां पे फ्रंटल इन्वर्जन. हाँ हाँ, वही तो 4 टाइप लिखा था ना इन्वर्जन में. कौन कौन सा 4 टाइप था इन्वर्जन टॉपिक में? देख लीजिए. रेडिएशन, सब्सिडेंस, मरीन एंड फ्रंटल. तो ये कौन सा हो गया? कंप्लीटेड. तो वहां पे लिखा था आपने, याद है? विल बी कंप्लीटेड एट द टाइम ऑफ फ्रंट्स. तो यहां पे आप लिख सकते हैं हेंस कंप्लीटेड. ठीक, सॉरी इसका. अच्छा हाँ, वेरी गुड. सो आप लोगों ने मुझे कल आकर के, बहुत सारे लोग आए थे ग्रेजुअली, और उन्होंने कहा कि सर 3D इमेजिनेशन हो नहीं पा रहा है. ओके, तो 3D इमेजिनेशन के लिए थोड़ा 3D टाइप का डायग्राम दिखाने का कोशिश करते हैं. ओके, शुड वी देखें? सो सबसे पहले आप सब इधर है अभी, मतलब है ना? एक होता है होना, एक होता है सही में होना. तो आप लोग सही में इधर ही है अभी? पक्का? ऐसा तो नहीं कि सर हाथ हो गए हैं, थोड़ा सेटल कर रहे हैं. हाँ, फिगर आउट नहीं हुआ है, रहना है नहीं रहना है. प्लीज सी दिस. So this is almost, suppose imagine this to be the ground, वो white lines भूल जाइए, right? And this to be the air. Can you see that grayish kind of air? दिख रहा है ना? मतलब ऐसा तो नहीं आप में से भी कुछ मेरे टाइप के हैं, थोड़ा कलर वलर उतना समझ में नहीं आता. दिख रहा है? So can you see that air part? Right? So assume that to be the cold air and this side to be the warm air. So what do you find here? यहाँ पे which air is pushing? The warm air is pushing the cold air. So ये कौन सा front बन गया? Warm front. And this side cold air is pushing the. So यहाँ पे कौन सा front बना? आया समझ में? ठीक है. And what direction is this? West this side, east that side. ठीक है. So east west direction. आ रहा है समझ में? ठीक है. And gradually this inversion will continue, और यहाँ पे you can see this warm air is rising. Can you see? Warm air rising upward. So once it rises, it will create clouds and rains and whatever. ठीक है. And similarly at the other end also you will have the rising air, यहाँ पे भी cold front के ऊपर. So that will lead to cold front formation and all. And can you see that bluish color thing? वो कौन सा air है? Cold air. So at one place cold air is being pushed, the other place the cold air is pushing itself. ठीक है. And this is what your cold front will look like. Obviously जैसा कल आप लोग कुछ बोल रहे थे कि सर वो थोड़ा ज़्यादा slant दिया हुआ है, तो that's okay, doesn't matter. But relatively it is more vertical than the warm front. ठीक है. So there you can see that. अभी दिख रहा है? Can you imagine now? सो ये दिख रहा है यहाँ पे आपका कोल्ड फ्रंट है, दिस इज ईस्ट वेस्ट डायरेक्शन ऐसा, राइट, एंड देयर यू सी ये क्या हो रहा है, व्हाट डू यू सी हियर, ऑक्लूजन, वार्म फ्रंट, कोल्ड फ्रंट, ईस्ट वेस्ट, इमेजिनेबल, ठीक है, वेरी गुड. सो दिस इज योर बेसिक फ्रंटल एंड सीन फ्रॉम अबव, दिस इज सीन फ्रॉम स्काई. सो ये नीचे ग्राउंड है, उसके ऊपर यू कैन सी द वार्म फ्रंट, रेड कलर एंड ब्लू फ्रंट. That blue color wala is your cold front, and then they are overlapping in this region. This is where they have overlapped. ठीक है, clear? Okay. So good enough. I find one thing very interesting in these classes, especially because this could be a character, this should be a character maybe at later stage, you know, जब आप मेंस का कोर्स कर रहे हैं या आंसर राइटिंग. बट आई डू फाइंड दैट इवन इन दीज क्लासेस, व्हाई डू यू ज्वाइन दीज क्लासेस? ऑफलाइन क्यों ज्वाइन करते हैं? एक तो सामने होंगे, है ना, इंटरेक्शन होगा, कुछ दूसरा स्टूडेंट से भी इंटरेक्शन होगा, फ्रेंड्स बनाएंगे, है ना. बट यहाँ पे मुझे दिखता है बहुत सारे लोग फिर भी अकेले ही बैठे रहते हैं, एकदम पीछे जा करके, ठीक है, या बीच में अपना आइलैंड ढूंढ लेते हैं, नो मैंस लैंड, जहां कोई ना हो. ओके, तो इसके पीछे कुछ रीजन है. डू यू कंसिडर अदर टू बी लोली पीपल? है ना, लोनली नहीं बोला है, लोली बोला है ना, लोअर ग्रेड, ये सब क्या करेंगे इनसे तो कंपटीशन ही नहीं है मेरा. ऐसा फीलिंग आता है आप लोग को? यार थोड़ा आसपास बैठा करो, कुछ दोस्त बनाओ लाइफ में, है ना. ये लास्ट स्टेज है, इसके बाद दोस्त नहीं बनने वाले. ठीक है, तो दोस्त मतलब ये नहीं कि सिर्फ क्लास में दोस्ती बनाना है. ऑल आई इंटेंड टू से इज व्हेन यू सिट टुगेदर यू डिस्कस एंड ऑल. ठीक है, तो मुझे भी बड़ा अजीब सा लगता है अकेले अकेले बैठे हुए हैं. ये दुनिया, ये महफिल मेरे काम की नहीं है. ठीक है, ओल्ड स्कूल होने तो पुराने गाने ही याद रहते हैं, नए वाले आप लोग को ज्यादा पता होंगे. हाँ, सो ओके गुड. मेरे ख्याल में आप लोग ने तो ये गाना सुना भी नहीं होगा ना? सुना है? अच्छा अच्छा, आप भी इसी गम के मारे हो. ठीक है ठीक है, मतलब सर एक बार मूड बहुत खराब था तो कहीं पे मिल गया. ओके ठीक है. सो एनीवेज कम बैक, गुड गुड गुड, कम बैक. तो कल से कोशिश करना है थोड़ा दोस्त बनाओ. ये लोग भी ठीक है, मतलब इतने बुरे भी नहीं है. ओके, आप भी ठीक है. नहीं तो वो जो 2-3 अकेले बैठे हो ना, आप ही लोग अपना एक ग्रुप बना लो. कम से कम 3 उधर बैठे रहोगे, लगेगा इनका भी कोई कोई तो है ना. ओके, सो गुड. सो कमिंग बैक, लेट अस गो बियॉन्ड दिस. इतना क्लियर है सबको, these diagrams etc, right? So finally what do we find? That the fronts tend to what you call as overlap, and they create frontal inversion and all this. So this much is clear, I assume. ठीक है, very good. Now in this diagram, as you can see, you find the subtropical. So I think हमने इनका नाम वाम कुछ लिखा है कल? नहीं. Frontal cyclones, mid latitude cyclone, subtropical cyclone, ये सब एक ही का नाम है. मिड लैटिट्यूड, फ्रंटल, वो सब है ना. टेम्परेट साइक्लोन, वो स्टार्टिंग में ही लिख लिया था, मुझे ऐसा ध्यान आ रहा है. ठीक है, सो एज यू कैन सी इन दिस डायग्राम, कैन यू सी द डायरेक्शन इन विच दीज साइक्लोन्स आर मूविंग? वेस्ट टू ईस्ट. व्हाई? बिकॉज ऑफ 2 रीजंस. हमने कल लिखा था. 1, दे आर ड्रिवन बाय वेस्टर्लीज, एंड सेकंड द जेट स्ट्रीम्स. ठीक है, एंड डज इट हैपन ओनली विद द पोलर फ्रंट साइक्लोन्स? नो, इट ऑल्सो हैपन्स विद the subtropical frontal cyclone भी ऐसा ही behave करते हैं. Some of you came to me and asked, sir, do we have to draw those diagrams, and can they ask us, even if they at all ask you subtropical temperate cyclones, you have to draw the same diagram. ठीक है, वहां पे भी you draw similar kind of a thing and you get through. Right? They will not ask you subtropical cyclone and polar frontal cyclone. They will ask you temperate cyclones. ठीक है, because your book does not separate the two. It just says in this region you have 2 regions where fronts are formed and 2 types of cyclones are formed. Is this okay? ठीक है, तो अभी आगे बढ़े इसका थोड़ा सा. So let us write down some of the important characteristics. some important characteristics of temperate cyclones. So they are formed in which latitude region? I'm giving you now the content as per your GC Leong and NCERT. ठीक है? So they are formed in the 35 to 65 degree latitude. They are formed in the 35 to 65 degree latitude region. Data might vary from source to source. You stick to NCERT and GC Leong. ठीक है? So 35 to 65 degree latitude, formed because of fronts. Formed because of fronts. Formed because of fronts. Cover large area. Temperate cyclones cover large area, 1000 to 2000 kilometers. Okay, next, they form over land and sea both. Temperate cyclones form over land and sea both. Form, underline, form, not travel, form. They form over land, they also form over oceans. Why? Because fronts can occur on both the region. Right? Front can occur on the land, front can also occur over the water bodies or oceans. Okay? Then, now because they are big, so they affect large areas. They affect large areas but have a moderate effect in general. Affect large area but have moderate effect in general. Next point, affect large areas but have moderate effect in general. So they have a moderate kind of effect. They do not have very severe effect like tropical cyclones. Though they will affect a bigger area, but they will have lesser effect. ठीक है? Why? Not why, because मतलब ये मैंने ऐसा याद रखा हुआ है. They are also known as family cyclones. Family cyclone. इनको हम family cyclone भी बोल सकते हैं. ठीक है? So if the question says what are family cyclones, these are family cyclones. Tropical cyclones are isolated cyclones. They are lonely cyclones. ठीक है? तो ट्रॉपिकल साइक्लोन कैसा है? लोनली, आप लोग टाइप का. ठीक है? और टेम्परेट साइक्लोन कैसा है? फैमिली, मेरे टाइप का. ठीक है? तो आप समझते हैं फैमिली मैन ज्यादा डिस्ट्रक्टिव नहीं होते, है ना? लोनली मैन और लोनली वुमेन ही ज्यादा डिस्ट्रक्टिव होते हैं. जब तक आप सिंगल है तब तक आप थोड़ा एक्सट्रीमिस्ट टाइप हो सकते हैं, है ना? किसी पे भी अटैक कर देंगे. फैमिली वाला बेचारा 4 बार सोचेगा, घर भी जाना है ना? बंद कर दिया जेल में तो आज सब्जी कौन लाएगा? ओके, आप लोग को कोई चिंता नहीं है, कोई बात नहीं, टिफिन वाला टिफिन रख जाएगा, देख लेंगे. ओके, सो मतलब दैट्स हाउ आई रिमेंबर दैट दीज आर व्हाट फैमिली साइक्लोन्स एंड दे आर लेस डिस्ट्रक्टिव. ठीक है? सो व्हाई, हाउ कैन यू से दे आर लेस डिस्ट्रक्टिव? बिकॉज द विंड स्पीड जनरली इन देम इज लेस, राइट? सो विंड स्पीड वहां पे आ जाइए. विंड स्पीड्स आर लेस. Wind speeds are less, 30 to 50 kilometer per hour. The normal wind speed range for them is 30 to 50 kilometer per hour. Next, rains are less and more distributed. Rains less and more distributed. Now, when the moment we say less, we are comparing with tropical cyclones. ठीक है? So all these less are with respect to tropical cyclone, not with respect to normal condition. वो normal से compare नहीं करना है कि सर आपने इसमें बोला था less rain, तो is it less than normal? No, it is less than tropical cyclones. Is this okay? ठीक है? So that's it. Broadly, this is it. Family cyclones हमने लिख लिया है. Why are we saying they are family cyclone? Because at least 2 of the cyclones will form together. Warm front cyclone and cold front. कभी भी अकेला warm front cyclone और अकेला cold front cyclone will never form. It can't. ठीक है? Because the moment you will have warm front cyclone, that means warm air is pushing into cold air. At the other end, cold air will be pushing into warm air and forming the cold front cyclone. So they will always form as a pair. Is that okay? Very good. So that's it. These are the broad characteristics of temperate cyclones. Clear? Now the last part with respect to India. The subtropical frontal cyclones, though we have written this line earlier also, but let me reiterate it. The tropical cyclones sorry, the what do we call subtropical cyclones, है ना, subtropical cyclones formed over the Mediterranean Sea and Caspian Sea. Mediterranean Sea and Caspian Sea within bracket as per IMD. Normal sources say as Mediterranean Sea. IMD adds which other sea? Caspian Sea. तो ये जो Caspian Sea का addition है ये IMD का साइड से लिया हुआ है, ठीक है. So subtropical cyclones formed over Mediterranean Sea and Caspian Sea, traveling towards the Indian subcontinent. Traveling toward the Indian subcontinent. Traveling towards the Indian subcontinent, comma, as they cross the northern regions south of Himalayas, northern regions south of Himalayas, comma, they are called as क्या बुलाते हैं इनको? Western disturbances, called as western disturbances, ठीक है, which start somewhere around November December, and continue. This is very important for you. Start somewhere around November December. So which season do they start in? Winter, and continue almost till May. Next year. May next year. As per, again within bracket, as per IMD. Because western disturbance का content आपका GC Leong और NCERT में ज़्यादा है नहीं. So which is the other dependable source that you can go to? IMD. Climate related कोई भी issue है नहीं समझ में आ रहा, there are two sources for you broadly. For Indian climate you can refer IMD, ठीक है. And when you go to world climate तो एक NOAA.gov वेबसाइट है, ठीक है. NOAA.gov US गवर्नमेंट का ये गवर्नमेंट वेबसाइट है. NOAA, National Ocean and Atmosphere Agency, something like this, right, .gov. तो वहां पे भी आपको बहुत सारा जनरल टॉपिक्स मिल जाता है, ठीक है. एंड बिकॉज इट्स एन अमेरिकन गवर्नमेंट वेबसाइट, सो इट इज प्रीटी ऑथेंटिक, और ज्यादा इधर उधर बात नहीं करते. दे विल गिव यू वेरी क्रिस्प कंटेंट द सेम वे एज IMD गिव्स यू, ठीक है. सो यू कैन रेफर टू दैट ऑल्सो. इन जनरल अगर उसके सिवाय किसी को करना है, अगर करना ही है, तो यू कैन ऑल्सो रेफर, फॉर एग्जाम्पल इंडियन क्लाइमेट, यू डू गेट कंटेंट ऑल्सो ऑन द ऑस्ट्रेलियन वेबसाइट समटाइम्स, बिकॉज वी शेयर क्लाइमेटिक कंडीशंस, ठीक है, स्पेशली व्हेन इट कम्स टू मॉनसून एंड एल नीनो ला नीना वगैरह. तो ऑस्ट्रेलियन गवर्नमेंट का साइट पे भी आपको कई बार प्रॉपर कंटेंट मिल जाता है. बट जनरली डू नॉट पिक फ्रॉम एनी सोर्स. ऐसा नहीं यूट्यूब में देखा और वहां से लेकर के आंसर लिख दिया, दैट वोंट हेल्प, ठीक है. बिकॉज एट मेनी ऑफ दी साइट द डेटा एंड द कॉन्सेप्ट देमसेल्फ आर गिवन रॉन्ग, राइट. तो आपको प्रॉपर सोर्स से ही लिखने का कोशिश करना, राइट. एंड मेनी टाइम्स दीज आर्टिकल्स ऑल्सो कम इन इंडियन एक्सप्रेस का एक एक्सप्लेन सेक्शन आता है, आई थिंक आप लोग फॉलो कर रहे होगे, राइट. उसके अंदर देयर आर डिफरेंट पीपल हु आर राइटिंग. इफ आई एम राइटली रिकॉलिंग वन ऑफ देम इज अमिताभ घोष और समथिंग. तो उसका आर्टिकल्स आर गुड, राइट. I'll get you the name also. Either I have not been following him for some time, but I do find his articles to be decently okay in terms of geography and all. ठीक है. तो कुछ मतलब you can refer these kind of source. ऐसा नहीं कि कहीं से भी कुछ भी उठाया मिला सर हमने तो लिख डाला. That won't help. Okay. आगे बढ़ें. Yes. So let us go beyond this. So temperate cyclone part broadly over. Now let us come to next thing. अगला टॉपिक क्या है? टेम्परेट का बाद कौन सा हमने सबसे पहला किया? पोलर वॉर्टेक्स, देन वी डिड टेम्परेट, एंड नाउ वी कम टू ट्रॉपिकल साइक्लोन्स, ठीक है. सो ट्रॉपिकल साइक्लोन्स इज द सब हेडिंग. ट्रॉपिकल साइक्लोन्स एंड रिलेटेड फिनोमेनास. So the moment we say related phenomena, tropical cyclones and related phenomena, जैसा कि temperate cyclones and we did some related phenomena also. Temperate cyclones से पहले हमने क्या क्या किया था? Jet streams, one, and fronts, दोनों air masses and front, because they were related, because until you understand air masses and front, you can't understand temperate cyclone. Same ways for tropical cyclone, you have to first understand what is the concept of intertropical convergence zone. ठीक है? So first we'll do the related phenomena and then we'll come to the tropical cyclone. Is this okay? So put the subheading intertropical convergence zone, comma, thermal equator and another comma and then doldrum. ये तीनों चीजें हमें साथ साथ क्लियर करनी है. Okay, ITCZ, thermal equator, doldrum. ITCZ, thermal equator, doldrum, ठीक है, and equatorial low pressure belt भी लिख लो, because all of them are related. There is some slight difference in all of them. Equatorial low pressure belt. अब इसमें से दो चीजें हम कर चुके हैं, equatorial low pressure belt and doldrum, ये दो हम कर चुके हैं. Now what is the difference between the two? What is equatorial low pressure belt? सबसे पहला, how will you explain, not define, but explain equatorial low pressure belt? It is the thermal, okay, it is formed by thermal process and creating a thermal low pressure region over around the equator, है ना? And this region is something like the equatorial low pressure. So it is a pressure belt. Very simply said, equatorial low pressure belt is a pressure belt. And what is it with respect to? With respect to pressure. So the moment you say equatorial low pressure belt, you are talking of pressure condition. You are not talking of anything else, right? So you have to write, because we have already written this. So यहाँ पे हम सिर्फ इसका additional point लिखेंगे. Equatorial low pressure belt is the zone with respect to pressure condition. Equatorial low pressure belt is the zone with respect to pressure condition. We won't write anything else, because the rest we have already written. Zone with respect to pressure conditions. So the moment you talk of pressure, you talk of equatorial low pressure belt. Now what is doldrum? Is it a pressure condition? No, it is a wind condition. Okay? So next, because we have written about these, so doldrum is the wind region. The doldrum region is the wind region. Wind region. Okay? Wind region where we find very weak winds. Where we find very weak winds. Wind region where we find very weak winds. Very weak winds. And does it coincide with the equatorial low pressure belt? Right? It is in that low pressure belt only that you have weak winds. Hai, so that also. Hence it is in the equatorial low pressure belt region. Doldrum is in the equatorial low pressure belt region. Right? So it is in the equatorial low pressure belt region. So it is a wind region which is in that zone. Okay? Now the third one. What is thermal equator? First let us understand thermal equator. What is thermal equator? Thermal equator. Word likh lo. We haven't done it, so let us do it first and then we go beyond. So what do we mean by thermal equator? What do we mean by equator first of all? Equator का मतलब क्या है? Equator is the latitudinal, separation or latitude which divide the earth into two equal halves when cut horizontally or when divided horizontally, keeping the axis of rotation vertical. Okay? So that is equator. Now what is thermal equator? Thermal equator, to understand that, please see here, all of you. Now, suppose we talk with respect to this. Okay? And okay, so in this diagram, all of you can see we have the equator somewhere here. Let me use different colors so that सबको साफ साफ दिखता रहेगा. So this is like your equator. Okay, and somewhere here you have the tropic of Cancer, and this side you have Tropic of Capricorn. ठीक है. And normally we can also draw some of the longitudes. Longitude भी बना सकते हैं ना इस पे. What will the longitude look like? ऐसा. This is one longitude, and maybe this is another longitude, and this is another longitude, and another one. Okay, and you can go on drawing different longitudes. ठीक है ऐसा. Maybe I'm not drawing perfectly well shaped, but I hope you understand. ठीक है. So something like this, you have the different longitudes. Now, if I ask you that in a 24-hour period, which are the places at different longitudes to have maximum temperature? For example, you can see that along every longitude there are different places. Now, if I ask you which place on a given longitude, for example, if I ask you on 35° east longitude, which place today had highest temperature? Can you tell me? When you can measure at different longitudes and you can tell me, right? Now, is it necessary that that place having highest temperature should be on the equator? Is it necessary? Why? Because temperature is affected by different factors. Insolation is one of them. It is affected by different factors. ठीक है ना? So by that logic, on any given day, you can create the location of places having highest temperature on different longitude. And for example, it can be something like ऐसा. Maybe you can say, sir, ऐसा होगा. And maybe on some of them it is on the equator, and maybe on some of them it crosses the equator also. हो सकता है ना? Is it possible? Right? Something like this. Right? And let us say again somewhere here. So you get this kind of set of places which are giving you highest temperature of that given day on that given longitude, not latitude. ठीक है? Clear? So for that given day, when you join these a line which will connect all these points, for that given day, you call this as the thermal equator. This becomes your thermal equator of the day. Thermal मतलब temperature. ठीक है? So thermal equator हो गया आपका. Same way you can calculate a thermal equator for the week. Week का average ले लो. Can you do it for a month? Can you do it for a year? So when you take the average of all the thermal equators of the day, you get week. When you take average of all the week, you get month. When you take the average of month, you get year. So this is how you draw thermal equator, depending on for which period you are being asked. Is this okay? So this is the thermal equator region. Is this clear? Now what is the temperature at the thermal equator? Highest for that given month, week, whatever day or year. Hence, what should be the pressure? And that low pressure will give you what condition there? Equatorial low pressure belt, because that's what your equatorial low pressure belt is. Do we agree? आ रहा है समझ में? So basically thermal equator is with respect to what? Temperature of that given longitude. ये बार बार latitude क्यों आ रहा है आंसर में यार? Latitude है या longitude है? Longitude. ठीक है? So thermal equator is with respect to temperature. Equatorial low pressure belt is with respect to pressure. Doldrum is with respect to wind. ये सब related है, but same नहीं है. आ रहा है समझ में? These are related things, but they are not same things. They are different. सब में थोड़ा थोड़ा difference है. एक temperature का aspect है, एक pressure का aspect है, एक wind का aspect है. Do we get it? Is this much clear? So should we write about thermal equator? लिख लें. Then we will come to equatorial low intertropical convergence zone in the end. वहां last में आते हैं. ठीक है? So write down thermal equator. So I hope you have written that subheading already, thermal equator. There you are writing that on any given day, week, month or year, on any given day, week, month or year, comma, for every given longitude, we can find or mark the places having highest temperature, for a given longitude. ठीक है, full stop. When we connect all such places for a given day, we get the what? Thermal equator of the day. We get the thermal equator of the day. And by taking averages, we can create, thermal equator for what? Week, month, year, whatever, right? Week, month or year. Hence, simply said, what is the simply said statement? नॉर्मली आप कभी भी कुछ पढ़ो तो कोशिश करो कि आप उसको एक सिंपली सेड स्टेटमेंट में बोल सकते हैं कि नहीं, ठीक है? अगर आप बोल पा रहे हो देन यू हैव अंडरस्टूड इट, और अगर आप बोल पा रहे हो दूसरा समझ भी पा रहा है, ठीक है? सो व्हाट शुड बी द सिंपली सेड स्टेटमेंट? क्या बोलना चाहिए? सिंपली सेड थर्मल इक्वेटर इज द लाइन कनेक्टिंग हाईएस्ट टेम्परेचर, नॉट सेम टेम्परेचर, हाईएस्ट टेम्परेचर ऑन डिफरेंट लॉन्गिट्यूड्स, ठीक है? Thermal equator is the line connecting highest temperature on different longitudes for a given period. Okay. And what should be the pressure condition on this? Normally this is also the line, along which what will lie? The equatorial low pressure belt will lie. Normally this is also the line along which the equatorial low pressure belt will lie or will form. Equatorial low pressure belt will form. ठीक है? And once you have equatorial low pressure belt, आपने पहले लिखा ही हुआ है that you will also get the doldrum around that, तो वो लिखने का जरूरत नहीं है बार बार, ठीक है? Now let us come to the next one. What is the next thing? Last topic यहाँ पे, हाँ जी. It is not dividing, it is the thermal line on both the sides of which the temperature is going down. So it is the maximum temperature line. So हम इक्वेटर से उसको हम मिसनॉमर है ये, बट जस्ट टू मेक यू अंडरस्टैंड दैट इट इज समथिंग लाइक द इक्वेटर, ठीक है? तो नाम बिल्कुल राइट नहीं है, कुछ और होना चाहिए था, राइट? बट इसको हम थर्मल इक्वेटर ही बोल देते हैं, ओके? बिकॉज थर्मल इक्वेटर का कॉन्सेप्ट होता है ना, मतलब इट इज ऑलमोस्ट इन द मिडिल काइंड ज्योग्राफिकली, तो यहां पे भी ऑलमोस्ट मिडिल है, दोनों तरफ टेम्परेचर डिक्रीज ही हो रहा है इसके, ओके? शुड वी गो बियॉन्ड? सो व्हाट इज द नेक्स्ट टॉपिक? इंटरट्रॉपिकल कन्वर्जेंस जोन. लिख लीजिए इंटरट्रॉपिकल कन्वर्जेंस जोन, सब हेडिंग डाल दो. यस, और आप बताइए डाउट. व्हाई डोंट वी टेक लैटिट्यूड? लैटिट्यूड तो ऑटोमेटिकली हो जाएगा ना. देखो गिवन लैटिट्यूड के ऊपर मान लो टेम्परेचर पूछा, सपोज आई एम आस्किंग, तो मान लो इंडिया में जो दिल्ली का जो लैटिट्यूड है उसमें दिल्ली पे है, ठीक है? उसका ऊपर का लैटिट्यूड पे आप जाते जाओ, So every given latitude might have maximum temperature, but that might not be the maximum for that region. है ना, 30 डिग्री लैटिट्यूड का मैक्सिमम हो सकता है इंडिया में हो, 60 डिग्री लैटिट्यूड का मैक्सिमम हो सकता है रशिया में हो, ठीक है, लेकिन वो 60 डिग्री लैटिट्यूड का मैक्सिमम लेके हमने किया क्या? दैट्स नॉट द मैक्सिमम टेम्परेचर ऑफ दैट रीजन. ऐसा तो है नहीं वो, क्योंकि वो तो आप पोल की तरफ जा रहे हो ना, ठीक है, तो वो लाइन तो पोल की तरफ बन जाएगी लॉन्गिट्यूड के जैसा. उसका कोई लॉजिक नहीं है, क्योंकि उसका तो इंसोलेशन से कुछ वैसा डायरेक्ट रिलेशन नहीं है. दैट विल ओनली शो दैट एज यू गो फ्रॉम इक्वेटर टू पोल टेम्परेचर डिक्रीजेस. ठीक है. व्हेन आई से लॉन्गिट्यूड, वी आर टेकिंग फॉर अ गिवन लॉन्गिट्यूड, ठीक है, जैसा इधर इसमें अब मान लो ये लाइन है. सो ऑन दिस लाइन फ्रॉम पोल टू पोल विच प्लेस हैज highest temperature? Same ways if you take this line from pole to pole, which place? Somewhere here. And you will find that always, almost always these places will be within tropics, right? Generally, almost always they will be between tropics. Very rarely they will go beyond tropic, because what is the normal temperature trend? As you go from tropic to pole, temperature decreases, है ना. तो ये normally हमेशा tropic के आसपास ही रहेगा. Okay, so let us come to ITCZ. ITCZ. Okay. अच्छा, ये last line I think we have already written. It normally remains within tropic. Just cross check. लिखा है ये? नहीं? Thermal equator में? So लिखना है हमें. The thermal equator normally remains within tropics. Thermal equator normally remains within tropics. Normally remains within tropics. ठीक है, अंडरलाइन नॉर्मली. नेक्स्ट ITCZ, इंटरट्रॉपिकल कन्वर्जेंस जोन. हाँ जी, बोलो बोलो. अप टू ट्रॉपिक्स, यस. तो सर आपने पहले तो कुछ और पढ़ाया था. चेंज होगा ना ग्रेजुअली, ठीक है. पहले दिन ही सब कुछ थोड़ी बता देते हैं, धीरे धीरे. ओके, सो आगे बढ़े. ओवर द पीरियड एज यू स्टडी मोर एंड मोर, थिंग्स वुड चेंज ऑल्सो. ठीक है, आई वुड बी एडिंग मोर कॉम्प्लेक्सर टॉपिक्स हेयर एंड देयर. अगर इतना ही आसान होता तो फिर क्लास की जरूरत ही नहीं थी ना. बट फर्स्ट आई विल टेल यू, जैसा आप केमिस्ट्री पढ़ते हैं तो सबसे पहले क्या बताते हैं? हाँ, इलेक्ट्रॉन और प्रोटॉन के बेस के ऊपर एलिमेंट बनता है. उसी दिन आपको सारे आइसोटोप्स तो नहीं पढ़ा देते. इसका आइसोटोप भी होता है. हाँ, वो सब पढ़ा है कभी? पहला केमिस्ट्री क्लास 1 के अंदर आइसोटोप्स, क्लास 1 नहीं 4, 5, जब भी आइसोटोप बहुत लेट आता है केमिस्ट्री में, है ना. तब आपको बताते हैं नहीं यार, हाइड्रोजन अकेला नहीं है, उसके 2-3 भाई बहन भी हैं, है ना. किसी किसी का इलेक्ट्रॉन इधर उधर होता रहता है. तो याद है, इलेक्ट्रॉन इधर उधर होता है आइसोटोप में, भाई देवे. अच्छा चलो छोड़ो, रहने दो, जा लेना, है ना. सब कुछ एक ही साथ नहीं कर डालेंगे. तो ठीक है, आगे बढ़े. ओके, आप हाँ बताइए बताइए. हाँ, टेम्परेचर मैक्सिमम यू कैन से, बट मिनिमम तो नहीं बता रहा है वो, है ना. तो रेंज के लिए तो आपको मैक्सिमम मिनिमम दोनों चाहिए. मैक्सिमम यू कैन से, ठीक है. ओके, एनीथिंग एल्स? नहीं. तो चलिए अब ITCZ पे आ जाते हैं. इंटरट्रॉपिकल कन्वर्जेंस जोन. व्हाट इज द फुल फॉर्म? इंटरट्रॉपिकल कन्वर्जेंस जोन. व्हाट इज द शॉर्ट फॉर्म? ITCZ. ठीक है. व्हाट इज द नेम टेलिंग यू? व्हाट डज द नेम टेल यू? इट इज अ कन्वर्जेंस जोन. ठीक है. वेयर इज इट लोकेटेड? इंटरट्रॉपिकल का मतलब क्या होता है? बिटवीन. जैसा आपका होता है ना इंटर कॉलेज कंपटीशन, इंटर स्कूल कंपटीशन, तो ये क्या है? इंटरट्रॉपिक. सो दैट मींस दिस इज अ कन्वर्जेंस जोन व्हिच इज बिटवीन द ट्रॉपिक्स, एंड इट इज व्हाट जोन इट इज? कन्वर्जेंस जोन. तो कन्वर्जेंस ऑफ व्हाट? क्या कन्वर्ज करेगा? टेम्परेचर, प्रेशर, विंड? क्या? विंड. सो इट इज अ जोन ऑफ wind convergence. And where does the wind converge? What type of temperature and pressure condition do the wind converge at? At which pressure condition? Low pressure. Which is the low pressure region here? Called as equatorial low pressure. And what is the temperature condition? High temperature. अभी आपने पढ़ा, what do you call that high temperature region as? Thermal equator. अभी पढ़ा ना आपने, ठीक है. And where the winds are converging, what is the type of wind on the surface? Doldrum. Very good. ठीक है, तो ये सब कुछ तो एक ही है, ठीक है, बट स्टिल सारे वर्ड्स में डिफरेंस है. आ रहे समझ में? ओके. फॉर एग्जाम्पल, योर प्राइम मिनिस्टर इज द हेड ऑफ हिज पार्टी ऑल्सो, एंड ही इज ऑल्सो द हेड ऑफ द गवर्नमेंट, एंड ही इज अ मेंबर ऑफ पार्लियामेंट ऑल्सो, और बहुत कुछ है ना. तो उसी तरह से उनका अलग अलग रोल है ना, चीज तो सेम ही है बट अलग अलग रोल है. उसी तरह से यहां पे भी अलग अलग रोल है हर एक का. डू वी गेट इट? सो इंटरट्रॉपिकल कन्वर्जेंस जोन, इफ यू हैव टू एक्सप्लेन टू समवन, सिंपली सेड क्या लिखेंगे? इंटरट्रॉपिकल कन्वर्जेंस जोन इज द जोन. अच्छा, जोन, लाइन, पॉइंट, एरिया, इनके बीच में डिफरेंस क्या होता है? अच्छा, पहला ये बताओ, ज्योमेट्री में लाइन, पॉइंट, एरिया और वॉल्यूम, इसमें क्या अंतर होता है? पॉइंट क्या है? सिंगल डायमेंशन. बोल सकते हैं सिंगल, पक्का, डायमेंशनलेस. ओके. और लाइन सिंगल, और पॉइंट तो हो गया, और एरिया 2 डायमेंशन, और वॉल्यूम 3 डायमेंशन. पक्का? वेरी गुड. तो अब ये बताइए कि ये जो आपने पहला 3 चीजें पढ़ी हैं, उसमें से वो सिंगल डायमेंशन क्या था? कौन सा लाइन आपने पढ़ा है? अभी पढ़ा है कोई लाइन आज? थर्मल इक्वेटर, दैट इज अ लाइन, है ना. सो थर्मल इक्वेटर हैज टू बी अ लाइन. आ रहा है समझ में? ठीक है. एंड व्हेन यू टॉक ऑफ द व्हाट यू कॉल एज डोल्ड्रम, सो डोल्ड्रम इज व्हाट? डोल्ड्रम इज इट एरिया, पॉइंट, वॉल्यूम? क्या है वो? वॉल्यूम. व्हाट वॉल्यूम? द एरिया, और दैट इज द जोन वेयर, और यू कैन से वॉल्यूम वेयर द विंड इज वीक. आ रहा है समझ में ना? ठीक है ना. राइट. प्रेशर बेल्ट, ठीक है. तो सबको इमेजिन करना है अपना दिमाग में कि ये कैसा जोन है, ये क्या है, क्या ये लाइन है, क्या ये पॉइंट है, क्या ये एरिया है, ठीक है. सो इक्वेटोरियल, व्हेन यू से इंटरट्रॉपिकल कन्वर्जेंस जोन, वो कैसा होगा? व्हाट इज हैपनिंग इन द इंटरट्रॉपिकल कन्वर्जेंस जोन? हो क्या रहा है? विंड्स आर कन्वर्जिंग. तो अगर हम इस डायग्राम में जाएं, ये वाला, because generally earlier what used to happen was that after all these classes students still used to come to me कि सर ये चारों का डिफरेंस समझ में नहीं आ रहा है, एक ही चीज है, ठीक है. So now if I ask you what is ITCZ in this diagram, where is the ITCZ? Intertropical convergence zone कहाँ है? It has to be the zone where the convergence is taking place. Where is the zone? Within tropic, where the trade winds are first of all converging and then rising. All the zone where they are converging and rising, all that zone becomes intertropical convergence zone. Are you समझ में? So in this diagram you can say whole of this region is ITCZ. Imaginable. Whole of this region is ITCZ. Where is the doldrum? Only this region. Doldrum तो यही होगा ना, where there is weak wind on the surface, क्योंकि doldrum तो surface condition है, near surface, ठीक है. So this is doldrum, this is ITCZ. Where is the thermal equator? Probably this line, something like this. यहाँ पे कहीं आपका thermal equator है. आ रहा है समझ में? ठीक है. So this is how these regions are. But then you have to show ITCZ in a 2-dimensional diagram. आपको तो मैप में दिखाना होता है, तो there you have to draw a line. So though for ITCZ we draw a line, but it is not just a line. ठीक है, it is a zone. वो एक बड़ा region है where the wind is coming and converging and rising. So all that zone is your ITCZ. Though we represent it only by a line, क्योंकि डायग्राम में आप 3 डायमेंशन तो ड्रॉ करोगे नहीं. अरे समझ में? क्लियर है? नो मेजर डाउट? राइट? शुड वी गो बियॉन्ड दिस? Okay. So now let us write this. ITCZ is the zone of convergence. ITCZ is the zone of convergence of the trade winds zone of convergence of the trade winds over the thermal equator due to the equatorial low pressure belt over the thermal equator due to the equatorial low pressure belt. I've connected all the three so that you understand the relation between them. Right, it's the zone of convergence over the equatorial low pressure belt due to the, over the thermal equator due to the equatorial low pressure belt. Okay? The surface region experiences the doldrum conditions. The surface region of the ITCZ, surface, near the earth surface. The surface or near the earth surface region experiences the doldrum condition. Doldrum condition. Okay. Now next, what is first of all, does the ITCZ remain constant round the year or should it keep moving? Why? Because the equatorial low pressure belt moves. And why does that move? Because of temperature. Okay. So because the equatorial low pressure belt moves, hence even the ITCZ should move. So next, ITCZ shifts with the shifting of pressure belt. ITCZ shifts with the shifting of pressure belt. Full stop. It normally remains within the tropics. Normally remains within the tropics, but in certain cases it does cross the tropics. Okay, as shown. Now please see look at the board. Can you see the two diagrams? मतलब can you see those two lines? दिख रहा है? दोनों के ऊपर कुछ लिखा हुआ है यहाँ पे, July and January. Can you see? So the dotted one is January line and the solid one is July line. These two lines are showing you the location of ITCZ. So the July ITCZ and the January ITCZ. Is this clear? Okay. Now where do you find the ITCZ to be? For example, the July ITCZ normally to be. Normally कहाँ होना कहाँ चाहिए? Northern hemisphere, southern hemisphere. Sorry? Northern hemisphere. Why? Because the sun is in the northern hemisphere. So second, it should normally be within the tropics. Do you find it always to be within the tropics? Where is it not within the tropics? Over India. Which season? Summer season. This is the special case or exception. ITCZ has this exception that in the summer season over India, when you have summers over India, the ITCZ crosses the tropic. Okay? And that's the only region in the world where it crosses the tropic. Only over India. Okay? Nowhere else it crosses the tropic. That's why normally it is always, मतलब इंडिया पे भी हम उसको इंटरट्रॉपिकल कन्वर्जन जोन ही बोलते हैं, बट देन व्हेन यू कम टू इंडिया वहां पे हम नाम थोड़ा सा बदल देते हैं. वी कॉल इट एज द मॉनसून ट्रॉफ. द वंस हु हैव रेड देयर एनसीईआरटी वुड हैव कम अक्रॉस दिस वर्ड मॉनसून ट्रॉफ, TROUGH. ठीक है. So why? Because that is the period when monsoons happen in India, and monsoon happen because of this. Is this okay? Are you me? So now we have to write that in the month of July, within bracket northern hemisphere summers. In the month of July, within bracket northern hemisphere summers, The ITCZ, the ITCZ remains in the northern hemisphere, remains in the northern hemisphere between equator and Tropic of Cancer. Between equator and Tropic of Cancer over most of the region. Equator and Tropic of Cancer over most of the region, except for the Indian subcontinent. Except for the Indian subcontinent, where it locates itself, beyond the tropic, up to the foothills of Himalayas, up to the southern foothills of Himalayas. Okay, north of the North Indian plains. North of the North Indian plains. I hope you remember the North Indian plains. Okay, so north of North Indian plains. Okay. Here it is known as the monsoon trough. Known as the monsoon trough. MONSOON, monsoon, TROUGH, monsoon trough. Put that within quotes. ठीक है, monsoon trough, comma, which plays a role in bringing monsoon to this region. Okay, so that ITCZ in India we call it as monsoon trough during summer, right? And it crosses the equator. Sorry, it crosses the tropic. Now come to winter. In the winter month, हाँ जी, आएगा, अभी कर लें, देख लेंगे जब हम मॉनसून तक पहुंचते हैं तब देखते हैं. ये सेंट्रल एशिया का हाई प्रेशर, हाँ, तो वहां पे हाई प्रेशर बनता क्यों है? क्योंकि वो एक्सट्रीमली कोल्ड है. वो सब हम मॉनसून के टाइम देखेंगे, यही मैं कह रहा हूँ. हाँ, शिफ्ट है. नहीं, ये उसकी वजह से ही नहीं है, ये इस रीजन के अंदर भी हाईएस्ट टेम्परेचर हो जाता है. जब आप थर्मल इक्वेटर देखोगे इस रीजन का, तो थर्मल इक्वेटर ट्रॉपिक के बियॉन्ड चला जाता है. For example, if I ask you, if you people remember, which region in India receives the high or gets the highest temperature during summer? Is it Gujarat and Maharashtra, or is it Rajasthan and Punjab? So for that given longitude, where should the thermal equator be? Rajasthan and Punjab and northern parts of UP. तो यहाँ पे सेंट्रल एशिया का कोई सीधा रोल नहीं, इसीलिए मैं बार बार कह रहा हूं कि यहाँ पे हम जब हम मॉनसून पे आएंगे तो बात करेंगे. ठीक है, ऑलराइट. सो डू यू अंडरस्टैंड? आपने पढ़ा होगा ना, न्यूज के अंदर आता रहता है, विच प्लेसेस गेट द हाईएस्ट टेम्परेचर? बाड़मेर, जैसलमेर, अमृतसर, है ना. तो दोज रीजन रिसीव हाईएस्ट टेम्परेचर. तो उसका वजह से ये है. ठीक है, वो होता क्यों है? कॉन्टिनेंटैलिटी, राइट. So we'll discuss that later on. Don't worry. When we come to India and monsoon, वहाँ देखते हैं इसे. But do you understand this much? इतना समझ में आ गया? Shifting is there. Do you get it? If you feel like, you can write one line. The shifting is mainly due to the high continentality of Indian subcontinent. The shifting is mainly due to high continentality of the northern parts of Indian subcontinent. The shifting is due to the high continentality of the northern parts of Indian subcontinent. Okay, now come to January month. January, high continentality of the northern parts of Indian subcontinent. Then January, in the month of January, which hemisphere will have highest temperature? The southern hemisphere. ठीक है ना? So you can write in the January month, the ITCZ. In January month, the ITCZ is expected to shift to the southern hemisphere. ITCZ is expected to shift to the southern hemisphere. Full stop. Next line. In the Southeast Asian region up to Africa, or from the Southeast Asian region up to Africa, इनका जगह from कर लीजिए, from Southeast Asian region up to Africa, the ITCZ shifts to the southern hemisphere. ITCZ shifts to the southern hemisphere. Please see here. Can you see Southeast Asia here? So from Southeast Asia up to Africa, the ITCZ does shift to the southern hemisphere. Can you see? But what happens beyond this is something that we have to now write, right? But over the tropical Atlantic, the southern tropical Atlantic has more maritime effect, hence moderate temperature, whereas the northern tropical Atlantic especially around West Africa, has more what? Maritime or continentality effect? Has more continentality effect. This region, when you compare this region with this region, यहाँ पे इन दोनों में, so this region has more maritime effect, this region has more continentality effect. So क्या होगा continentality effect के वजह से? That region will remain warmer. Why? Because it is tropical only. Subtropical तो है नहीं, equatorial tropical region remains warm. So this region has higher temperature and this region has lower temperature. So where will the thermal equator be and the ITCZ be? Around this continent. ठीक है? So though this region has summer, but this region being equatorial tropical experiences still the highest temperature. So the ITCZ still remains here only, यहाँ पे. Can you see this? ठीक है? So the ITCZ, right? So we write hence the ITCZ does not move. Hence the ITCZ does not move to southern tropical Pacific. Does not move to southern tropical Pacific and continues over western tropical Africa, because the region remains relatively hotter, Okay. Now, when you come to South America, once you have crossed that region, when you come to South America, in South America, because of high continentality, you can see here, the ITCZ is coming in the southern hemisphere. दिख रहा है? So in South Africa, interior region, ITCZ does come to southern hemisphere. But the moment you go to the ocean again, ITCZ is again shifting to the northern hemisphere. Why? Because this coastal region has a cold ocean current. यहाँ पे एक cold ocean current है. हमने जब ocean currents किया था तो I have drawn. This side we had a cold ocean current. What will cold ocean current do? It will make this region relatively colder और ये वाला region remains relatively warmer. ठीक है? Do we get it? So should we write this? लिख लेते हैं. In South America, extremely sorry, thank you. मैंने आप लोगों को पहले ही बताया, जब आप लोग थोड़ा ऐसा घूर देते हो मुझे तो मुझे लगता है कुछ तो गड़बड़ हुआ है ना? So in South America, in February, January, February, right? Or winters, whichever way you write. अच्छा नहीं, यहाँ winter नहीं है ये. So it's better to write January only. In South America, in January, the ITCZ does shift to southern hemisphere. In the continental interior, ITCZ does shift to southern America. I'm so sorry, आज कुछ तो हाँ. So ITCZ does shift to southern hemisphere due to high continentality region, whatever. In the high continentality region या जो भी लिखा है, right? Southern hemisphere due to high continentality. But as we move towards tropical eastern Pacific, this region is what? Tropical eastern Pacific. ठीक है? Tropical eastern Pacific, comma, due to the presence of cold current, क्या नाम था? Humboldt current. I don't know whether I've given you the name there. You can write the name here. Humboldt current. HUMBOLT. Humboldt current. BOLT. Bolt. Humboldt. ठीक है? Humboldt current. The region remains relatively cooler. The region remains relatively cooler, and the hotter temperature conditions even during these months is found in the northern hemisphere, tropical Pacific region. And hence the ITCZ remains there. ठीक है? So now, simply said, if I ask you, which are the regions in the world where ITCZ never goes? Huh? Hence, simply said, the ITCZ never moves to which two regions? Tropical, southern, Atlantic. Can we say? Around the year, the ITCZ never moves to tropical, southern, Atlantic and tropical ईस्टर्न पैसिफिक. बोल सकते हैं ना? ठीक है? प्लीज डू राइट दिस. सिंपली सेड, ये सब तो हम लॉजिक समझ रहे थे अभी तक. ठीक है? नाउ व्हाट इज द फाइनल आउटकम? राइट? सो सिंपली सेड राउंड द ईयर द ITCZ never moves over the southern tropical Atlantic, as well as southern eastern tropical Pacific. Okay, but we have focused here on the word eastern. Remember, eastern tropical Pacific है, western or central tropical Pacific नहीं है. Because if you see in the diagram, by the time you reach close to the western Pacific, it does come to the southern hemisphere. So only in the eastern tropical Pacific it doesn't. Is that okay? Clear? Very good. Now let us come to, so that's it. This is what we needed to learn about ITCZ. ITCZ topic is also over. Now we come to tropical cyclone. So should we put the subheading tropical cyclone? ठीक है, ज़्यादा ओवरलोड तो नहीं हुआ है, आगे बढ़े. Very good. So tropical cyclones. Okay. And let us try to understand the formation of tropical cyclones first. So please see. And I would like you to, maybe draw on one side of the page, almost 3/4 of your page you should be drawing, and 1/4 of your page you have to write a few conditions. ठीक है, तो 1/4 में conditions for tropical cyclone लिख लीजिए. You are writing vertically, right? And 3/4 of the page you are drawing the diagram so that everything is fitted, right? So I'll also give you the conditions for tropical cyclone formation. क्या लिखेंगे हम साइड में? Conditions for ट्रॉपिकल साइक्लोन फॉर्मेशन. आई एम राइटिंग टीसी, आप टीसी मत लिखना, एटलीस्ट एक बार तो ट्रॉपिकल साइक्लोन पूरा लिख लेना, नहीं तो बाद में ट्रांसफर सर्टिफिकेट लेते रहोगे. ठीक है, सो ओके, सो ट्रॉपिकल साइक्लोन फॉर्मेशन. सो व्हाट आर द कंडीशंस? फर्स्ट ऑफ ऑल, ocean surface, right? Ocean surface, and what type? Warm ocean surface, and temperature should be more than 27 degree Celsius. So that's the first condition for tropical cyclone formation. What? Warm ocean surface, temperature more than 27 degree Celsius. So where does the tropical cyclone form? Unlike the temperate cyclone formed over ocean and land. ये कहाँ बनता है? Only ocean, right? So that condition you have to write. Forms only over ocean. Only over ocean. Forms only over ocean. And any ocean या any specific temperature? Warm ocean having temperature more than 27 degrees. Only over ocean. Warm. Second condition, warm temperature more than 27 degrees Celsius. ठीक है, so only over ocean with temperature more than 27 degree Celsius. ठीक है, okay. And third, during warmer season, right? It does not form during the colder season, so it forms during warmer season, right? So summer up to the beginning of winters you will find it. Starting from summers up to the beginning of winters. Summers up to the beginning of winters. So for example, in India, when do we have summers? Start somewhere around May, June, okay, and continues almost till the beginning of winter. कब होता है हमारे यहाँ? November, December. ठीक है? So you can write, for example, in the Indian region, it starts to form around May, June, and continues almost till November, December. Now why till November, December? Because November, December is actually cold. है ना, कोल्ड सीजन हो जाता है दिसंबर, नॉट एग्जैक्टली नवंबर, बट बाय दिसंबर यू गेट कोल्ड सीजन. बट Now please try to see here, understand one characteristic. Land has a characteristic that it heats and cools fast. Water heats and cools slow. So when during the summer it is heating up, by which time does it become the hottest? Just before the beginning of winter. Okay, when does the ocean become warmer, or till when does it remain relatively very warm? Just before the winters. Okay, because till then it goes on gradually heating up. So almost till October, November you will find the ocean temperature to be relatively one of the warmest, and then gradually it again starts to slightly cool down. Is this okay? Because the water tends to cool or heat slow, right? So if you want, you can write this one character, that water tends to heat and cool slow. Water tends to heat and cool slow. Hence till the beginning of winters. Water tends to heat and cool slow. Hence almost till the beginning of winters. Hence almost till the beginning of winters, the ocean waters are relatively warm. Ocean waters are relatively warm. Okay, very good. So now let me also take up diagram which I will utilize for making you people understand this. Right, so let us say we come to this region, ठीक है, और यहाँ पे I'm just rubbing all those additional content that we have. ये सब का हमको अभी ज़रूरत नहीं है. ठीक है, so this is the Indian subcontinent, and somewhere here you will have the equator, ऐसा. Right? So we have one side you have Bay of Bengal, the other side you have Arabian Sea. Clear? So can this, अच्छा वो line गायब हो गया, ऐसा. So now we can say that this region will be relatively warm round the year, or sorry, during the summer season. है ना, not round the year, during the summer season it will be warm, which means whole of Bay of Bengal might be warm and whole of Arabian Sea is warm. Maybe the whole region might have a temperature of 27 degrees. So will the tropical cyclone form everywhere in the Bay of Bengal and Arabian Sea? Have you ever heard कि पूरा मतलब you know during throughout the summer everywhere you are getting tropical cyclone? ऐसा तो है नहीं. Which means tropical cyclone will have some more additional conditions. So first condition was over the ocean. Second condition was warm ocean temperature condition. Now here these two conditions are fulfilled. That's perfectly fine. But we still don't get a tropical cyclone. So what is the other condition that we need? Should we understand? The other condition is that you need a additional low. Why? Because this whole region already has a low. क्योंकि सब जगह ही warm temperature है. So this region already has a low, but then you need some additional low condition also. Right? An add-on low condition is required for tropical cyclone formation. So which are the conditions you have already written? First, over the ocean. Second, temperature more than 27 degree. Third, write down the next condition. The third condition is it requires a additional low pressure condition. It requires a additional low pressure condition. Additional low pressure condition. In addition to the low pressure due to warm temperature. In addition to the low pressure due to in addition to the low pressure due to warm temperature condition. Full stop. This additional low pressure is provided by ITCZ. ITCZ. Because what is ITCZ? Intertropical convergence zone. And where is it formed? Around the equatorial low pressure. है ना? So wherever you will have ITCZ, you will have the low pressure. Additional low pressure. I hope you agree. ठीक है? So what was providing the additional low pressure in case of temperate cyclone? टेम्परेट साइक्लोन में वो एडिशनल लो प्रेशर किसने दिया था? जेट स्ट्रीम. याद है? और यहां पे कौन दे रहा है? ITCZ. In all cyclones you require an additional low pressure. You just have to understand who's or what is providing it. So in this case it is provided by ITCZ. Where is the ITCZ during summer season? It is somewhere between equator and tropic, and it keeps moving, right? So as you go from equinox to solstice, it will go on moving like this, and then as you come from solstice back to equinox, it will again move like this. So that means that in this region the ITCZ is moving somewhat like this and this, and while it is moving like this, it will come over the oceans also. So let me draw one of those positions, right? So let us say the ITCZ is somewhere here, ऐसा, ठीक है? So in that ocean it is already providing a low pressure यहाँ पे. The ocean is warm and all, and along this line you also have a additional low pressure. Is this understood? आ रहा है समझ में? Now if the ITCZ was somewhere here, suppose यहाँ पे है, right? Here also you have additional low pressure, but for cyclone formation you need a whirlpool, and for whirlpool you need which additional force? Coriolis force. And around the equator will you get the Coriolis force? No. So will you have cyclone forming around the equator? No. ठीक है? So that is the next condition, right? That for substantial Coriolis force, cyclones form beyond 5 to 10 degree latitude. For substantial Coriolis force, cyclones form beyond 5 to 10 degree latitude, beyond 5 to 10 degree latitude, and not in the equatorial region. Beyond 5 to 10 degree latitude and not in the equatorial region. Clear? ठीक है? So out of the two lines 1 and 2, where should I expect the tropical cyclone to form? हाँ, 2 पे ज्यादा चांस है, 1 पे कम है, वहां पे बनेगा नहीं because the Coriolis force is not there. Is that okay? So let me rub that second line. ये वाला line हटा देते हैं इसमें से. So somewhere here you will expect the ITCZ to form. So right? आ रहे समझ में? So now let us try to draw that diagram. अभी इसका diagram बनाते हैं. Suppose this is the region, and let us say we have the additional low pressure somewhere here. तो वहां पे मैंने लिख दिया LP. So this region has the additional low pressure due to ITCZ. ठीक है? Now once you have the low pressure here, how will the wind start behaving? कैसा behave करेगा? Is this thermal low or mechanical low? Thermal. How will the air starts behaving around the low pressure? Horizontally, in or out? Horizontally inward. ठीक है? So in this region the winds will start moving horizontally inward, right? और ये जो diagram है इसके अंदर you can draw the tropopause also, so that you get a sense कि आप कौन सा direction से देख रहे हैं इसको. This is tropopause, and something like this is east-west. ठीक है? Please do have those direction and tropopause, so that you understand कि structure बना कैसा रहे हो आप. Right? So horizontally inward and vertically, how should the wind behave vertically? Vertically outward. Something like this, right? And if I draw over the whole ocean region, where let us say another diagram for the same thing, I'm drawing another diagram where I'm showing you north, south, east, west like this, ऐसा. East, west, north, south. This means you are seeing the second diagram from which angle? Above. Sky से देख रहे हैं. So you are seeing it from an aeroplane in the sky. From there you are seeing the whole Bay of Bengal or Arabian Sea region. So how will it look like? The low pressure will be something like this, ऐसा. बीच में एक low pressure होगा. And around that low pressure, winds will try to move horizontally, inward, but spiraling or radially? Spiraling, which means the winds will come from all directions, somewhat like this. Can you imagine? And in this region, they will tend to move spiraling inward. Yes or no? So from surrounding region, they will tend to spiral, and then when they will come around the low pressure, then they have to vertically rise also. ऐसा. ठीक है. So that vertical rise thing, first they spiral in and then they vertically rise. So vertical rise इसमें कैसे दिखा सकते हैं? This is the region where the wind will try to vertically rise. Yes or no? So first it is trying to come in, spiral, and then vertically rise. ठीक है? So I'm drawing both the from both dimensions. I'm trying to show you the diagram. Here you are seeing standing and here you are seeing from above. ठीक है? दोनों डायग्राम साथ साथ बनाते जाओ. And वो east west north south will get you a sense. That's why I have drawn tropopause ऊपर वाला डायग्राम में. ठीक है? All right. Once you have drawn, then we'll go to the next thing. And थोड़ा सा बड़ा डायग्राम बनाना है इसका. You need slightly bigger diagram because you have to add more things. ठीक है? स्पेशली ये वाला दोनों डायग्राम थोड़ा बड़ा बनाएगा. बहुत ज्यादा छोटा मत बनाना. यू माइट नॉट अंडरस्टैंड लेटर और इट विल बिकम हॉच पॉच. ठीक है? सो सर ये सब इंस्ट्रक्शन थोड़ा पहले दे दिया करो. हमारा इतना हार्ड वर्क वेस्ट हो जाता है. सर इज इट इंपॉर्टेंट टू ड्रॉ डायग्राम्स इन एवरी ज्योग्राफी क्वेश्चन? देख लो यार, मतलब क्या बोलूं मैं आपको. मतलब जरूरी नहीं कि सब में ही बना डालेंगे, बट कोशिश करो, अगर हो जाए तो गुड. ओके, समथिंग दैट इज रेलेवेंट शुड बी डन. दिस इज हाउ यू डिफरेंशिएट योर ज्योग्राफी आंसर फ्रॉम ऑल दी अदर आंसर्स. है ना? ज्योग्राफी आंसर में ही स्कोप है डायग्राम बनाने का. अब हिस्ट्री में डायग्राम किसका बनाओगे? बना सकते हैं, ऐसा नहीं है. मतलब आप बोल सकते हो सर बना सकते हैं, उसमें ही बन सकता है. ठीक है, बट बहुत सारा टॉपिक्स है जिसमें अब पॉलिटी में भी डायग्राम बोलो कि सर इंडिया का मैप बना के दिखेंगे, कॉन्स्टिट्यूशन ऑफ इंडिया इज फॉर दिस रीजन, तो वो उतना अच्छा नहीं लगेगा, है ना? बट फिर लगेगा इसका ज्योग्राफी ऑप्शन है, तब ये हर जगह मैप दिखाना चाहता है. बट एटलीस्ट यू कैन ड्रॉ. ठीक है, एटलीस्ट इन ज्योग्राफी यू कैन ड्रॉ, यू हैव दैट स्कोप. ओके, कम बैक. सो नाउ द मोस्ट कॉन्सेप्चुअल पार्ट विद रिस्पेक्ट टू ट्रॉपिकल साइक्लोन. ठीक है? सो यू शुड ऑल बी प्रीटी फोकस्ड फॉर द नेक्स्ट 10 minutes बिकॉज आई एम गोइंग टू आस्क यू क्वेश्चन एंड यू विल आंसर. अब आप साइक्लोन खुद बनाओगे, जितना कुछ मुझे बताना था वो हो चुका है. ठीक है? सो शुड वी रेडी टू गिव आंसर्स? ठीक है, वेरी गुड. सो प्लीज कम हियर एंड टेल मी एंड जस्ट गो ऑन थिंकिंग लॉजिकली. यू विल गेट ऑल द आंसर्स योरसेल्फ. दिस इज अ लो प्रेशर ऑलरेडी क्रिएटेड, सरफेस इज वार्म, ये सब हमें समझ में आ रहा है. सो व्हेन द विंड इज मूविंग ओवर द सरफेस, व्हाट इज इट पिकिंग फ्रॉम बिलो? One, it will pick moisture. And how does it pick moisture? By evaporation. And when evaporation is happening, heat, is it being picked or is it being released? The heat is being picked from where? From the ocean. So this air is picking the heat from and also the moisture, or rather we can say it is picking the moisture, along with it is also picking the heat. Do we agree? So heat and moisture dono pick hua, and then gradually that heat and moisture will go up as it goes on rising. As it rises, what will start happening to the temperature? Temperature will start decreasing, and hence the air will start cooling. So as it cools, where does the heat go? The heat is released to the surrounding. Aa raha hai samajh mein? So gradually as this air rises, it will cool down by giving the heat to the surrounding. So if it gives the heat to the surrounding, gradually what will happen to the surrounding temperature? Warm or cool down? The air is cooling down, but the surrounding will warm up because it is giving heat to the surrounding. Can you imagine? ये heat give हो रहा है, ये जो arrows है, ये heat giving arrows है. So heat is being released, and in this process, what will happen to the moisture? It will start condensing or further evaporation. Condense, and when it will condense, it will lead to formation of cloud. So cloud formation will happen. और यहाँ पे rise कैसा है? Vertical या inclined? So what type of cloud should I expect? हाँ, vertical clouds such as cumulonimbus. आ रहे समझ में? So in this case we start getting the formation of cumulonimbus clouds. ठीक है? So should I draw some cumulonimbus clouds also? बना दे. उसी में थोड़ा let us say something like this. You get the cumulonimbus cloud formation. So some cloud formation is also happening. है ना? Yes or no? Cumulonimbus cloud formation दिख रहा है? And vertically, both the diagrams can you see? So it will create a cylinder of cumulonimbus clouds. Cylinder, can you imagine? A vertical cylinder of cumulonimbus cloud बन गया ना? ठीक है? If you see the whole thing, is it not like a cylinder? ठीक है? Now the second thing, will this cumulonimbus cloud region also be receiving some warm or hotter, heat from the surrounding? वो भी heat हो रहा है. So basically you can say that this region will over a period become, this region, not the cloud, the region will become warm. Now when this region will become warm, the air in that region will tend to become stable, or will it continue to rise? When you heat up any air, it tends to rise. Pakka? Everyone agrees? If that air rises, ये वाला air, if this air is rising, right, what will it do to the surface? What kind of pressure will be created on the surface? High or low? If you are taking away the air, ऐसा, so it will do high pressure or low pressure? More air or less air? So what pressure? Low pressure. If it is low pressure, then more surrounding wind will move in or out? So basically initially the wind was moving in, went up, created upper region warming. When the upper region warmed up, the lower region became stronger, low pressure. So more air will come in. Now when more air will come in, and let us say the ocean is still warm, what will happen? It will pick more heat and moisture, and that heat and moisture will go up and create more cloud and release more, and that region will become more, and hence the surface low pressure will become further stronger. So it is becoming a self-sustaining system. Can you see? Right? Now till when will this process continue? Till the ocean is able to provide heat. Moisture तो हमेशा ही है ocean में, but till the ocean is able to provide, and for that the ocean should be warm enough, not just warm. Not any warm ocean will give you. The ocean has to be warm enough, which means a huge volume of the water has to be warm. It's not only the surface, because the surface water can cool. But if up to some depth the water is warmed up, right, then there will be enough heat in the ocean, and that heat can gradually be picked up by the system. Do we understand this? ठीक है. So ultimately होगा क्या? Not ultimately, मतलब in this process what will go on happening? What will go on happening? This whole system will become stronger or weaker? Stronger का मतलब क्या है? हो क्या रहा है यहाँ पे? Clouds more or less? Winds, low pressure, further strong low pressure, further stronger winds, further cloud formation, further heating up, and the whole process becomes more and more intense or moderate. So gradually if the process becomes more and more intense, that's your tropical cyclone. आ रहा है समझ में? So where does the tropical cyclone get its energy? Tropical cyclone is destructive, you must have heard. सुना है ना? It is highly, but for destruction you need, for any process you need energy. So you have to understand where is it getting the energy from. So where is this thing getting the energy from? Ocean, the tropical oceans. It is the heat of the tropical ocean which creates the tropical cyclone, or it is the supply of the energy. क्योंकि जब तक एनर्जी नहीं है तब तक उसके अंदर उतना एनर्जी नहीं आएगा कि इट कैन क्रिएट सो मच डिस्ट्रक्शन, सो मच रेन, सो मच, सो इट हैज टू पिक द एनर्जी फ्रॉम सम प्लेस. एंड वेयर इज द पावर सोर्स? Ocean. So till this will be over the ocean, will it become stronger or weaker? Stronger. Are you understanding? So this is exactly your tropical cyclone formation. But then there are some more conditions. थोड़ा condition और भी है. Should we add? ठीक है. So should we? I hope you understood the sequence. But अभी ये complete नहीं हुआ है. ठीक है. Why? Because just imagine, suppose as this air is rising upwards, यहाँ पे, this rising air, if it continues to rise, and let us say in the upper atmosphere there is some condition which does not allow it to further rise. Upper atmosphere, ऐसा condition है that it is converging condition. Suppose, so if there is a converging condition in the upper atmosphere, will the wind rise? Because horizontally also it is converging and vertically also it is coming into the same region, so it will not support. So basically the rise will gradually be suppressed, and if the rise is suppressed, will the cyclone build? Because for the rise you need the wind to continuously go on rising, and in the upper atmosphere how should it be? Diverge. So what is the next condition for cyclone building? Upper air divergence, surface low pressure convergence, and upper air divergence. So there should not be any kind of converging condition or blocking condition in the upper atmosphere. What is the most suitable condition? Divergence. So you write in that condition thing. Upper air divergence. Upper air divergence is a necessary condition. Upper air divergence is a necessary condition for tropical cyclone formation. Something like this. So please do draw upper air divergence. और वहां लिख भी लेना है अपर एयर डाइवर्जेंस. ओके, so upper air divergence is a necessary condition. All right, good enough. Now the last part of the story. Now just imagine that on the surface you have, easterly winds and whatever, because of which the winds are coming like this, and let us say somewhere in the middle, so let us say here you have a wind coming like this, which is the easterly wind, okay, whereas in this region, upper air, you have, or middle air, you have a wind which is going like this. Okay, so near the surface the wind is somewhat like trade winds, इस type का, and in the middle or upper atmosphere you have a wind which is going in somewhat like this direction. Just imagine you have two winds having too much variation. So vertically there is too much of variation in the wind. One side wind is going one way, the other side wind is going, or the other level wind is going the other way. In this case, what will happen to the vertical structure of the cyclone? Will it be strengthened or disturbed? Everyone understands? क्योंकि दोनों विंड उसको ऐसा टिल्ट कर देंगी and the whole cyclone will become tilted, and you can't have a tilted kind of formation क्योंकि वहां पे तो convection होएगा ही नहीं. Convection will try to rise vertically and the cyclone formation is tilted. So cyclone will get disturbed, so it will not form. Okay, so what should be the vertical wind condition? It should be too much of variation or very less variation? Very less. So vertically the wind variation should be less. Do you understand? Okay, so vertical wind variation should be less. That's the next condition. Okay, vertical wind variation should be less, and we call this as the vertical wind shear. इसी को हम बोलते हैं वर्टिकल विंड शेयर. आपका एनसीईआरटी में लिखा हुआ है एक वर्ड, वर्टिकल विंड शेयर. सो वर्टिकल विंड वेरिएशन शुड बी लेस. ठीक है, वर्टिकल विंड वेरिएशन शुड बी लेस. So it should be relatively uniform. The wind should be vertically uniform. Now there is one more dimension to this vertical wind shear. Please try to understand. ठीक है, vertical wind shear should be less or uniform. ठीक है. Now another aspect of this vertical wind shear is, please see here, all of you, just try to understand. As this wind is spiraling upward, suppose that at some place it is spiraling very fast and at some place it is spiraling very slow. Then what will happen? Some place the spiraling upward is fast, so at some place it is stretching very fast, some places it is not stretching fast. Then what will happen to the uniform shape of the cyclone? Will it become relatively more uniform or it will become distorted? And it might break also. Where it is stretching fast, it might break because from below wind is not rising. Okay? So this is the second aspect of vertical wind shear, that the vertical wind should be, vertical movement of wind should be uniform. ये इसका दोनों मतलब है. ठीक है, वन, वर्टिकली एट डिफरेंट लेवल द विंड शुड बी यूनिफॉर्म एंड द वर्टिकली राइजिंग विंड शुड आल्सो बी रिलेटिवली uniform. It should not be that up to 2-3 kilometers it is moving very fast and after that it is moving slow or something. Then it will create accumulation. At some places it will be accumulated, at some places it will be broken. So the cyclone will not build up because wherever it is broken, that means that region will not have heat, and if there is no heat, it will not further rise. वो rise हो क्यों रहा था? हीट का वजह से. तो जब जहां पे विंड बहुत स्लो है, सॉरी जहां पे विंड बहुत फास्ट है, वहां पे तो हीट एक्यूमुलेट नहीं होगा. ठीक है, so if that region becomes cold, then that region will not push the wind upward. So again the cyclone will build, break up. So what do you need? Uniform, so that everywhere you have uniform heat, so that continuous uniform rise is there. ठीक है, so you can write this. Also means vertical wind shear also means, vertical wind shear also means that vertically rising wind should not have much variation. Vertically rising wind should not have much variation. And hence should be relatively uniform. Hence should be relatively uniform. Okay, do we get it? इतना clear है? Any major doubt? No? So now give me the conditions. फटाफट जल्दी से रिवाइज मेरा करा दो, उसके बाद I give you a break. बोलो बोलो, start from first. Which region? Land or ocean? Ocean. Cold or warm? Which season? Summers or winters? Summer. Starting from summer. ठीक है, starting from summer almost till the beginning of winters. Very good. What temperature? More than 27 degrees. Warm water more than 27 degrees. Close to equator or away from equator? Why? Coriolis force. ठीक है. And will only this much suffice or you need additional low pressure? Additional low pressure generally provided by ITCZ. That's the role of ITCZ. ठीक है. So now if I ask you which region tropical cyclones will not form in the world, and which tropical regions in the world tropical cyclones will not form? आपका कॉपी में सुबह ही अभी लिखा है आपने. Which two regions, which two tropical region tropical cyclones will not form? Eastern Pacific. Eastern Pacific या Eastern Tropical Pacific? वो दोनों आंसर देंगे आपको. ठीक है, ऐसा नहीं सिर्फ सीधा ईस्टर्न पैसिफिक पढ़ा और लिख डाला. ठीक है, नीचे ईस्टर्न ट्रॉपिकल पैसिफिक भी था, नहीं तो फिर बाद में घर आके क्या करना पड़ेगा? बताया था ना एक बार, नहीं बताया? हाँ, कि घर आके क्या करना पड़ता है? ठीक है, तो घर पे नहीं करते रहो, इसीलिए, ठीक है, ओके। देन सेकेंड रीजन, सदर्न ट्रॉपिकल अटलांटिक, अटलांटिक, वो अटलांटिक पैसिफिक थोड़ा क्लियर होना चाहिए। इज दैट ओके? दीज टू रीजन्स वी जनरली डोंट फाइंड ITCZ and hence no tropical cyclone. आगे बढ़ जाए, ठीक है। Then what is the next thing? So you have this thing and hence the winds, because of that what is created over the ocean? Low pressure. Around the low pressure wind starts to horizontally spiral inward, horizontally spiral inward, picking heat and moisture from the warm ocean and then vertically rise upward, spiral and vertically rise upward, creating which clouds? Cumulonimbus clouds, and releasing heat into that vertical region. Is this okay? So in that vertical, so gradually this vertical region will become, gradually the vertical region will become warmer or colder? Warmer, and hence the whole system will start becoming self-sustaining, because more and more wind will rise, stronger low pressure, more moisture and heat picking, and the whole system becomes more self-sustaining. आ गया समझ में? Right now, what do you call this cylindrical cloud region as? We call it as the eye wall. And what do we call that low pressure region as? ये दो नाम है, the eye. ठीक है? So this low pressure region is known as the eye of the cyclone. Low pressure region, eye of the cyclone, and this as the eye wall. Eye wall. And what is the eye wall made up of? Eye wall made up of cumulonimbus clouds and heat. That's where the heat is storing. ठीक है? Eye and the eye wall. ठीक है? Eye wall. Eye wall, because it's a cylinder wall. It is like a hollow cylinder. So किसी सिलेंडर का साइड्स को क्या बोलेंगे? वॉल ही बोलेंगे ना, सिलेंडर का वॉल. ठीक है? So eye wall. Very good. Now what is the next condition? Next condition, upper air divergence, so that the vertical rise will continue. ठीक है? So upper air divergence, right? And then lastly, vertical wind shear should be uniform and low, right? Low. So low, why? So that the wall does not stretch and break. ठीक है? The vertical wind speed, if it is very much variable, the wall will break, and even if the vertical winds are very variable, the wall will break. ठीक है? So the structure of the cyclone remains intact. ठीक है? And ultimately the whole thing is built up. So finally your cyclone is built. Is this okay? तो आपको समझ में तो आ ही गया? Perfectly fine. Now there are some small parts here and there which we have to add to the diagram. वो सब कर लेंगे. Concept समझ में आ गया? Any major doubt? आप ही ने बताया. ठीक है? So अभी अगली बार साइक्लोन खुद बना लोगे? हाँ? मतलब बना लोगे ना? हाँ, डायग्राम ही बनाना है. ठीक है? So perfectly fine. So let us take a quick break here. Okay, and let's meet in 15 minutes and then we start. So any major thing? Right. So all right. So the formation part have we written? Nahi na? We have just written the condition and the diagram. So let us write the formation of the tropical cyclone. Formation of tropical cyclone. Okay, so under this write down formation of tropical cyclones. नहीं, वो साथ वाला क्लास से ज़्यादा डिस्टर्ब नहीं होना, इन्फ्लुएंस भी नहीं होना, इधर फोकस करिए। कोई बात नहीं, वो भी खुश हो सकते हैं यार, उनका भी लाइव है, ये थोड़ी बस आप लोग यहाँ बैठ के हंसते रहो और वो वहाँ पे बोले, ठीक है। सो ओके, कम बैक। सो राइट डाउन when the required ocean surface temperature is reached, when the required ocean surface temperature is reached, and the ITCZ is present, and the ITCZ is present, it leads to the low pressure region known as the I, leads to the low pressure region known as the I, and winds start to spiral, and winds start to spiral inward towards the eye. Winds start to spiral inward towards the eye. Spiral inward towards the eye. Picking heat and moisture. Picking heat and moisture over the ocean surface. Picking heat and moisture over the ocean surface. Full stop. As the winds reach the eye, as the winds reach the eye, they start to spiral vertically up. They start to spiral vertically up and gradually condense. Gradually condense. Yes. Gradually condense. अच्छा, मैं थोड़ा तेज बोलूं, will that help? है ना? Gradually condense. I can understand background noise है. Sir, can we just ask the staff to inform them थोड़ा सा कम हंसे? Okay. So as the wind starts to and gradually condense, leading to formation of vertical clouds, leading to formation of vertical clouds within bracket cumulonimbus clouds. Cumulonimbus clouds. Full stop. In the process also release heat. In the process also release heat, warming up the eye wall region. In the process also release heat, warming up the eye wall region. Eye wall region, which causes further rise of the air, further rise of the air, and hence more moisture and heat picking. More moisture and heat picking over the ocean. Moisture and heat picking over the ocean. Full stop. Gradually the process becomes the process becomes self-sustaining because more heat in the eye wall causes more heat picking from the ocean. More heat in the eye wall causes more heat and moisture picking from the ocean. Also, due to upper air divergence and uniform vertical wind shear, upper air divergence and uniform vertical wind shear, the process continues and the cyclonic condition process continues and the cyclonic condition gets further strengthened. And ultimately a cyclone builds up. Okay, so this is the building of the cyclone. Clear? Any major doubt? No. Yes. In the ocean surface temperature is reached. So ocean surface temperature is around at 27 degrees Celsius or higher. वो जो शुरू में लिखा था reached है ना, reached. Ocean surface temperature is reached, did I say? So reach क्या है, वो 27 है और higher. Till the ocean surface temperature is less than that, it won't happen. ठीक है? Clear है? I think वो कुछ होने शायद weak सुना गया. Okay, so just correct it to reached. R-E-A-C-H-E-D, reached. ठीक है? Which means 27 or more. Clear? अच्छा, should we go beyond? So formation of the tropical cyclone is clear? Okay. अभी अगला क्या है? Movement of the tropical cyclone. Right? Any major doubt? Clear है? So now next, movement of the tropical cyclone. Movement of tropical cyclone. So how does by the way, in which winds are the tropical cyclone formed? Which region? Which wind region? Easterly. So what should be the direction of the east to west, right? So we have to write movement of the tropical cyclone. Under that, right, because it is formed in the easterly region, hence tropical cyclones move east to west. Towards the ITCZ, because that's where the trade winds converge. East to west towards the ITCZ. Okay, so that's how they are moving. Now, other characteristics of tropical cyclones. So please see here. This is a NCERT diagram. Okay, in this diagram there are many things which are drawn, and hence it is slightly confusing. You don't have to read all, you don't have to remember the whole thing, you don't have to even draw the whole thing. The only thing that you need to understand here is, you have a low pressure, the eye, the wall, the rising winds, the upper air divergence, is this much is clear, and up to tropopause. यहाँ तक तो पहला clear है. Now what additional things do you find? In addition to the vertical winds or the vertical clouds, you also find rain bands. What are these rain bands? Rain bands are, you can imagine them like, some kind of divergence happening from the middle of the wall. So as the winds are rising, some clouds and winds tend to diverge even in the mid layer. Not go up to the top, they slightly diverge in the sides. Okay? So in our structure, it would be a divergence somewhere you can say somewhat in this kind of a region. Yes, sir. Right? So some divergence like this, because of which clouds tend to spread, and these will spread relatively horizontal. So they will create some horizontal cloud, and this will actually give a bigger shape to the cyclone, because one, the cyclone is like this, and some cloud is going sidewards also. So it is, because it is coming out of the same thing, you can just imagine it like a tree. The branches of the tree going sidewards. So one is the trunk of the tree, and then there's the branches of the tree. So these are like branches of the cyclone, where the clouds tend to go sideward, and from them also you will get some rain. Hence we call them as rain bands. Okay. So that rain band also I need you to draw in the diagram somewhere. Okay. In the middle structure itself, you can just draw cloud stretching. So those cloud stretching are your rain bands. Okay, clouds and rain band. Clouds as rain bands. Means around these region also you will find rain. So rain is not happening only here in this cloud, in this region. The rain would happen even in the surrounding region. The way if you are standing below the tree, so wherever the branch of the tree is, water might fall. If there is water on that, some water will fall from that. Okay, so just imagine something like this. Right, so that basically makes the whole affected area bigger for a cyclone. Okay, one. Then second thing that you find in the diagram of importance is that you can see in this diagram there is some wind which is subsiding. Okay, as wind tends to rise, it tends to heat up or cool down normally. Normal. As the wind rises, it cools down. So when it will come down, it will heat up. This is a normal tendency of wind. Okay. So when the wind tends to sink down, it tends to warm up because it gets compressed. Adiabatic heating है ये. Okay. Heating due to compression. Okay. So as the wind will tend to come down, it will tend to warm up. That's why we call sinking air as warm air. Is that okay? Okay. Now what happens is, now just imagine and you will get the answer. Why this happens is, this eye wall has a very low pressure, right? Because gradually this has become extremely low because of the cyclonic condition. But the winds which are coming from the side do not reach the eye wall. Okay, so it is a low pressure region, but the winds are not reaching it. Why? Because before they reach, they tend to rise. जैसे इक्वेटोरियल लो प्रेशर पे हो रहा था. Yes or no? What was happening? It was a very strong low, but winds do not reach the equatorial low pressure region. They rise before they reach there. Similar thing is happening here. Eye wall is a very low pressure, but the winds don't reach the eye. Sorry, the eye is the very low pressure region, but winds don't reach the eye. Why? Because before they reach, they rise. Okay. Now, if they are rising, so the demand of the eye for wind will remain because it is not getting any air, and it cannot get the air from the wall. So which is the other option from where it can expect some air and try to pull some air up? So it tends to pull some air downwards. That downward pulled air tends to subside as warm air. And as it subsides, will it cause rain and cloud? Sinking air, does it cause rain and cloud? No. So it will be clear weather. So over the eye, what kind of weather should I expect? Clear weather. Over the eye region, the weather is clear. All surrounding it, there is a cyclone, right? But just at the eye, it is clear and calm condition. Do we understand? Right? So we have to write this also. Right? So just add that warm air subsiding in the diagram, and then we write. At the eye of the cyclone, there is a subsiding warm air, eye of the cyclone, there is a subsiding warm air, giving clear sky conditions, subsiding because giving clear sky condition, comma, subsiding because the low pressure of the eye does not, subsiding because the low pressure of the eye does not receive winds, low pressure of the eye does not receive winds from the surrounding eye wall, does not receive wind from the surrounding eye wall. Okay, hence the eye has a clear weather condition. Hence, the eye region has a clear weather condition. Eye region has a clear weather condition, clear, calm weather condition. Eye region has a clear and calm weather condition. All right? Right? Now, please see this diagram and write the dimensions also. For example, what is the size of the eye? 16 to 30 kilometers. Okay, so something like 15 to 30 kilometers is the eye width. Okay, so the size of the eye is something like 15 to 30, मतलब वो 16, 32 ऐसा मत लिखो आप, 15, 30 ऐसा लिख लो, round numbers. 15 to 30 kilometers is the eye. What is the wall? 30 to 65 kilometers. ठीक है, so eye wall one side 30 to 65, other side 30 to 65 kilometers. ठीक है, this is the size of the eye wall, thickness of the eye wall. Cylinder है ना, तो उसका thickness होगा. So thickness is 30 to 65 kilometers. So if you say from wall to wall, what is the width of the whole cyclone? Around 65 plus another 30 plus another 65. So nearly 160 kilometers. This width of the cyclone. Right? That is just wall to wall thickness. The wall to wall size of the cyclone might be up to 160 kilometers. Wall to wall. Okay? And we have still not added the rain bands, because that is also the region of influence. है ना, rain band भी तो था ना ऊपर जो ऐसा spread हो रहा है. That is also cloud, rains. ठीक है? So 60 to 6, hopefully you have written the size, right? So you can write the wall to wall width of the cyclone is around 160 kilometers, right? And when we add up the rain bands, etc., when we add up the rain bands, etc., when we add up rain bands, it might stretch from 600 to 1200 kilometers. When we add up the rain bands, it might stretch from 600 to 1200 kilometers. 600 to 1200 kilometers. Okay. Is it bigger than the temperate cyclone? Temperate cyclone was 1000 to 2000. This is 600 to 1200. So this is still only 60% of temperate cyclones in terms of size. Okay. But when you say that size, you don't mean wall to wall. We mean rain band to rain band. Okay. Clear? Is this okay? Very good. So this is the size of the cyclone. Now, once you understand the size of the cyclone and the movement of the cyclone, इतना clear है? ठीक है? The different terms for the cyclone in different regions. This is your NCERT content, ये वाला. So what are the different terms of the cyclone in different regions? If you want, you can write this. This is given in your NCERT, वही content है. But still, ठीक है? So in the Indian Ocean, we call it as Chakravat. That's the Hindi word that we have for that. Atlantic, we call it as hurricanes. West Pacific and South China, we call it as typhoons. And Western Australia, we call it as willy willies. So it's the same thing called by different names in different regions. All right. Now other characteristics. Tropical cyclones strengthen over the oceans. They strengthen over the oceans. Characteristics, other characteristics of tropical cyclone. Other characteristics of tropical cyclone. They strengthen over the ocean. Right? But what should happen when they reach the land? Will they pick the heat and moisture from land? Can you have a 160 to 600 kilometer wide region from where they can pick heat and moisture on the land? इतना बड़ा तो कोई land पे water body होता नहीं है. A river is a very small water body. You can understand. है ना? When the whole cyclone is 160 kilometer wide, no river can provide so much of heat and moisture to it. ठीक है? So over land, tropical cyclone starts to weaken. Over land, tropical cyclone starts to weaken. Over land, tropical cyclone starts to weaken. Next, the wind speed in tropical cyclones. Wind speed in tropical cyclones can reach up to, wind speed in tropical cyclones can reach up to 250 kilometer per hour. Reach up to 250 kilometer per hour. What was the wind speed in temperate cyclone? टेम्परेट साइक्लोन आज सुबह लिखा है आपने अप टू 50-60 किलोमीटर लिखा है ना 50-60 किलोमीटर 35 या 32 टू 60 समथिंग ऐसा लिखा है ना सो ऑलमोस्ट अप टू 50 किलोमीटर इज द विंड स्पीड इन टेम्परेट साइक्लोन यहां कब तक है व्हाट इज द हाईएस्ट up to 250 kilometers. So can you understand how different it is? Right? This is not, though it is a cyclone, but this is a very different cyclone from the temperate. Therefore, temperate cyclones were less destructive. This is a very destructive cyclone. Okay? Write down further. It can move, the tropical cyclones can move 300 to 500 kilometers per day. They can move 300 to 500 kilometers per day. This is what a tropical cyclone looks like. You can see the eye of the cyclone, दिख रहा है बीच में, okay, and this is the cloud and it's spiraling. So this speed, this one is up to 250 and this speed, the whole cyclone moving 300 to 500 kilometer per day, this one. So when the cyclone is moving itself, that is 300 to 500 kilometer per day. And what direction? East to west towards equator या towards ITCZ? ITCZ. ठीक है? Then write down further. Where the tropical cyclone hits the land, where the tropical cyclone hits the land, the location is known as, where the tropical cyclone hits the land, the location is known as landfall. The location is known as landfall. What is the term for the place where the cyclone falls? Landfall. So wherever it hits the land, we call it as landfall. ठीक है? Then next, at the landfall, it creates, at the landfall region, it generally creates a very destructive phenomena known as storm surge. Very destructive phenomena. Landfall, it generally creates a very destructive phenomena known as storm surge. Very destructive phenomena known as storm surge. STORM, storm surge. Storm surge. Right? What is a storm surge like? A storm surge is like this. Can you see this? Okay. So what happens? Because of low pressure near the land, the water is risen. And because of the high wind speed, the water moves at very fast speed also. So the water might be risen by few meters. Okay, up to 4-5 meters the water can be risen. And the wind speed is up to 250 kilometers. So the water speed can reach up to 40-50 kilometers, 60 kilometers per hour. So it is like a small tsunami type only. Can you imagine? Tsunami में कितना water जाता था? up to 30 meters, and यहाँ पे it is up to 4-5 meters. So it's a small height, but 5 meter is also not less. 5 meter means almost 2 floors. ठीक है, something like this. So this is also a good height, all right, or at least 1 floor. 2 नहीं है तो 1 तो है ही. Okay, so that much water might rise and hit. So that water might hit the coast and cause destruction on the coast. ठीक है, we call this as storm surge. So that image you can draw something like this. देखो ये है normal condition where the water is not risen, and the second one is where the water has risen and hit the coastal region and destroyed the construction. दिख रहा है? So something like that we call as a storm surge. So we have to write storm surge due to low pressure. Storm surge is caused due to low pressure and high speed of the storm surge is caused due to low pressure and high speed of the winds, causing the ocean water to rise by up to 5 meters, causing the ocean water to rise by up to 5 meters and move at high speed into the coast, causing destruction. Hence they are the most destructive of all tropical cyclone phenomena on the coast. Okay, so we understand what is a storm surge. Clear है? Should we go beyond? आगे लिखिए. Because these are characteristics, this is pretty factual thing. Now, please do write, as the cyclone moves beyond the landfall, it causes the destruction. As the cyclone moves beyond the landfall, it causes destruction on the coast or over land, but also gradually becomes weak. Full stop. In some cases it can cross the land. And reach the ocean on the other side. And if suitable conditions prevail, it can again further strengthen. Okay. For example, some tropical cyclones from Bay of Bengal cross the peninsular India and again strengthen over the Arabian Sea. Alright, so this phenomena does happen, but it doesn't happen very often, it happens sometimes. Okay, then next, please see here. Why is the cyclone moving in this direction if I ask you? ऐसा क्यों move कर रहा है? It is trying to reach towards ITCZ, which means maybe the ITCZ is somewhere here. Now just imagine the cyclone was moving like this, ITCZ was somewhere here, okay, and then all of a sudden, because of some condition, the ITCZ tends to, by the time the cyclone had a landfall, the ITCZ reaches somewhere here, suppose. Now will the cyclone try to continue to go in the same direction, or will it try to bend? It will tend to curve. This is known as the curving of the tropical cyclone. Many times after landfall, the cyclone might curve. Why? Because earlier there was a low pressure on the land, now the low pressure is nearby in the ocean. Okay? If there is a low pressure created nearby in the ocean, the whole cyclone might gradually turn around that. And once it turns, it will still continue to go to higher latitudes. As it goes to higher latitude, which force will strengthen? Coriolis force. So what will happen to the cyclone? Cyclone will also become stronger. The curving and the whole rotation will become more strong. So gradually after landfall, it can recurve. Once it recurves, it can become stronger over the ocean. Because after landfall, it was supposed to become weak. But if it goes back to the ocean, it will not become weak. It will further become stronger, picking more heat, moisture, and going to higher latitude, and hence become more stronger. Do we understand? So this phenomenon is known as recurving of tropical cyclone, which makes the cyclone stronger. ठीक है? So should we write this? लिख लें? Write down. Many times cyclones change direction after landfall. Cyclones change direction after landfall. And rather than moving over land, they recurve towards the ocean. They recurve towards the ocean due to various factors. They recurve towards the ocean due to various factors such as change in position of ITCZ, change in position of the ITCZ, or a nearby low pressure condition created. Or a nearby low pressure condition created. Also, due to this, the cyclone now picks more heat and moisture. Due to this, the cyclone picks more heat and moisture over ocean. Due to this, cyclone picks more heat and moisture over the ocean. And also Coriolis force strengthens at higher latitude. Coriolis force strengthens at higher latitude. Hence, cyclone also strengthens. Coriolis force strengthens at higher latitude. Hence, cyclone also strengthens. ठीक है? Is this clear? So recurving of cyclone and this thing is also most probably done, understood. So that's it. These are some of the broader characteristics of the tropical cyclone that we had to do. Okay, now the next part is naming of the tropical cyclones in different parts of the world. Right? Naming of tropical cyclone. For example, you might have heard nowadays when the newspaper article come, they give a name to the cyclone. अभी कौन सा आया है 2-3 दिन पहले? हाँ? थोड़ा सा लाउड बोलिए. आप राइट बोल रहे हैं, घबराइए नहीं. आसानी है ना, आसानी से आ रहा है, नाम ही आसानी है. ठीक है, तो इसीलिए इसमें कुछ घबराने का जरूरत नहीं है. ठीक है. Okay, so the recent one that we had was आसानी, ऐसा ही मतलब देखो उसको वैसा याद रखोगे नहीं, लेकिन ऐसा याद रखो आसानी से आ गया, ठीक है, तो फिर यू विल हार्डली फॉरगेट इट, right? So now we give names to tropical cyclones. So how are these names given to the tropical cyclone? This is what we have to understand. Is that okay? So naming of tropical cyclones, right? So write down under that. Starting from the year 2004, starting from the year 2004, 2004, under the WMO, under the WMO, WMO क्या है? वर्ल्ड मीटेरोलॉजिकल डिपार्टमेंट और ऑर्गेनाइजेशन, नॉट डिपार्टमेंट, ऑर्गेनाइजेशन, ठीक है. सो वर्ल्ड WMO एंड ESCAP, ESCAP, इकोनॉमिक एंड सोशल काउंसिल ऑफ एशिया एंड पैसिफिक, ठीक है. ESCAP दैट इज UN ESCAP, वो UN का ही बॉडी है, राइट. इकोनॉमिक एंड सोशल काउंसिल ऑफ एशिया एंड पैसिफिक, ESCAP. The in 9 regions of the world, in 9 regions of the world, naming of tropical cyclones was decided. 9 regions of the world, naming of tropical cyclones was decided. Write them. Which are the 9 regions? Write them. Eastern North, Central North and Western North Pacific. Eastern North, Central North and Western North Pacific. Eastern North, Western North Pacific and Central North Pacific, right? And Southern Pacific. तो 4 तो Pacific का regions हो गया, Eastern, Central and Western North Pacific and Southern Pacific. So 4 regions in Pacific. Then write for Atlantic. North Atlantic, North Atlantic and South Atlantic. North Atlantic and South Atlantic. So how many regions done? 6. Then Australian coast, Australian coast, and then come to Indian Ocean. North Indian Ocean, North Indian Ocean and Southwest Indian Ocean. This is a prelims question, hence I am giving you. Which region? So these are the regions. North Indian Ocean and Southwest Indian Ocean. Okay, in these 9 regions it was decided. Then write down further. In these regions, 6 regional specialized meteorological centers. 6 regional specialized meteorological centers and 5 regional tropical cyclone warning centers. 6 regional specialized meteorological centers and 5 regional tropical cyclone warning centers. 5 regional tropical cyclone warning centers have been identified with respect to tropical cyclones. Next, IMD is one of the 6. IMD is one of the 6 RSMCs. IMD is one of the 6 RSMC, Regional Specialized Meteorological Center. One of the 6 RSMCs to provide tropical cyclone and storm surge warnings. To provide tropical cyclone and storm surge warning to storm surge warning to 13 member countries. 13 member countries of this region. So इन 13 member countries को कौन देता है ये warnings? IMD. ठीक है, 13 member countries of this region. Which region is this? Northern Indian Ocean region. Of the Northern Indian Ocean region. So IMD is for Northern Indian Ocean region. आपने 9 regions लिखा है ना, वहां पे एक Northern Indian Ocean region है. Okay, so for Northern Indian Ocean region, IMD is the RSMCs. Is that okay? ठीक है, and it gives warning to 13 countries of this region. Now, which are the 13 countries? The 13 countries are these 13. Please see the name. दिख रहा है आप लोग को कुछ बोर्ड पे दिख रहा है? Names are visible. So I'll zoom and move alphabetically. सबसे ऊपर, then जो भी आप लोगों ने बोला, ठीक है, उसमें पाकिस्तान मुझे थोड़ा सा साफ से सुनाई पड़ा, वहां पे आपका एफर्ट था और मैं भी थोड़ा इंटरेस्टेड था. ठीक है, सो वी गिव साइक्लोन वार्निंग इवन टू पाकिस्तान. ठीक है, IMD गिव्स, एंड दिस इज वन ऑफ द climate cooperation related aspects of weather cooperation thing. So with your countries in neighborhood, you don't only have economic relations, we also have other climate, weather, disaster related cooperations. So this is one place where IMD cooperates with. जैसा अभी रशिया और यूएसए का इतना कुछ चल रहा है, लेकिन ISS पे दोनों का अब उनका वो लाना है वापस एस्ट्रोनॉट, तो क्या करेगा? अमेरिका तो ला नहीं सकता, तो बेचारा अभी कोलैबोरेट कर रहा है उनके साथ. हाँ ठीक है, कोई बात नहीं यार, ला दो हमारे बंदे भी वापस, उसके बाद देखते हैं. ठीक है, so IMD, and it's not that in a war time or something IMD will not tell. At all times we will. ठीक है, because this is not, so this is how countries are becoming interdependent on each other. The more the interdependence, the less chance of war would happen between any two countries, any two regions. ठीक है, so coming back, हाँ जी, नीचे कर दीजिए, ये लीजिए. ठीक है, so these are the 13 countries. Now what is, how do we name them? So now let us come to naming. So for naming the cyclones, every country in every region gives a list of names, and those names are from their own regional context. जैसे आप इंडिया का नाम पढ़ो, Indian names, which are the names India has given? Second line, गति, फिर तेज, हाँ, आग, व्योम, झार, नीर. So all of them have a Indian context, right? When you see the same for other regions, right? So for example, when you see for Pakistan, देख लो, मतलब है ना, मतलब ऐसे मजे नहीं लेने हैं, but you can understand the, so for every region you can, so every country gives its own contextual name, which are names generally in that region, right? And for example, please, so earlier in our region we had 8 countries, and 8 countries had given 8 names, right? Recently 5 more countries have been added, so now we have 13 countries. और वो 13 कंट्री ने सबने 13 नेम्स दिए. सो IMD हैज प्रिपेयर्ड अ लिस्ट ऑफ कितना नेम? 169 नेम्स. ठीक है, सो 169 नेम का उनके पास ऑलरेडी लिस्ट है. नाउ एवरी टाइम अ साइक्लोन विल कम, ऑल दे हैव टू डू इज दे हैव टू नेम, राइट, इन द सीक्वेंस, ऐसा, राइट? सो दे विल नेम, एंड देन वंस दैट फर्स्ट list is done, then they will go to second list, then third list, fourth list, and they will go on naming. So names for next, अभी last वाला कौन सा आया? आसानी, वो कहाँ का नाम है? श्रीलंकन नेम. After that, which will be the next cyclone? हाँ, सितरंग. उसके बाद, so ये 4-5 नाम ऐसा ही लाइफ में याद रखना है. जैसे जैसे एग्जाम हो रहा है, कोई भी आएगा उसको बता सकता है अगला साइक्लोन बताऊं कौन सा आने वाला है. ठीक है, 2-4 का नाम बता दोगे, बोलेगा यार ये तो सही में इसका तैयारी कर रहा है, इसको तो फ्यूचर साइक्लोन्स भी पता है. ठीक है, सही. उनको नहीं पता कि यार ये सब नाम तो पब्लिक डोमेन में है. ओके, ऑलराइट. सो मतलब ऐसा ही, जब छोटा मोटा कुछ इंप्रेस करना हो किसी को तो ये सब करते रहा करो. ठीक है, ओके, सो दे विल ऑल्सो थिंक हाँ ये पक्का आईएएस का तैयारी कर रहा है। जैसे चाय बनाया तो बोले तुमको पता है लिथोस्फीयर भी ऐसा बनता है। वो बेचारा चाय नहीं पिएगा आपके साथ, पता नहीं क्या क्या मिलाया हो लिथोस्फीयर बनाने में, ठीक है। सो okay, good. So I hope you understand. So this is how your naming is done, and we are already done up to a part of the name. And so once the list will be done, then what will happen? IMD will again call all the countries to submit name, and the countries do not submit like that. IMD वो newspaper में article देखता है, please give your names. So people submit name, and out of that list, IMD selects a few. ठीक है, तो ऐसा नहीं कि IMD अपने मन से देता है, वो भी वो न्यूज़पेपर में डाल करके आप सबसे मंगाता है, प्लीज अपना अपना कुछ सजेशन दो, साइक्लोन को नाम देना है. ओके, एंड वॉट एवर नेम्स आर इजी टू रिमेंबर, दोज नेम्स आर in general picked and given. Is this okay? So do we understand the whole process? Clear hai? So this is how cyclones are named, right? And whenever you want this name list, you can always Google and get it on the net. Okay, very good. So naming done. Now let us come to the next thing. So now the next thing is, when does IMD call something as a cyclone? Because IMD have to give the warning and it has to give a name. So when does the IMD give or call any phenomena as a cyclone? ये हम कर चुके हैं. विंड स्पीड लिखा था हमने पहले, हाँ, डू यू रिमेंबर? विंड स्पीड आपने लिखा है, ड्रॉप नहीं, प्रेशर कंडीशन जब हम कर रहे थे, डिड वी राइट? हाँ, वो लिखा है, लो डिप्रेशन एंड साइक्लोन, बस उतना ही लिखा है, उसके आगे तो नहीं लिखा है. हाँ, तो वो लिखना है हमें, ठीक है. सो नेक्स्ट सब हेडिंग, वंस यू अंडरस्टैंड द नेमिंग, नाउ राइट डाउन, you can write, for example, the IMD maintains a list of name given by the 13 countries. IMD maintains a list of name given by the 13 countries, and one of the name is given to every new cyclone. One of the name is given to every new cyclone in the northern Indian Ocean. The IMD maintains a list of name given by the 13 countries, and one of the name from the list is given to every new cyclone in the northern Indian Ocean region. This is only for the northern Indian Ocean region, because IMD does it only for northern Indian Ocean region. One of the name is given from the list to the new cyclone in northern Indian Ocean region. Okay. Next, when does IMD call a low as a cyclone? When does IMD call a low as a cyclone? Okay, so let us try to understand, right? And this is also pretty much human type behavior, okay? So that will help you understand. Abhi I'll tell you how. Please see. Now first we'll write the pressure, and then not the pressure, sorry, the wind speed, because IMD talks in terms of wind speed and term. Okay, what term it uses? So for example, when the wind speed is less than 31 kilometer per hour, when the wind speed in that low pressure condition is less than 31 kilometer per hour, till that it is called as a low condition. उसको हम क्या बोलते हैं? Low condition. ठीक है? And I said this is pretty much like human behavior, क्योंकि हम भी ऐसा ही behave करते हैं. जैसे कि मान लो कोई थोड़ा सा लो ऐसा होता है ना, कई बार थोड़ा not feeling good, तो आप क्या बोलते हो? यार लो क्यों फील कर रहे हो? Why are you looking low? है ना, थोड़ा मूड बूस्ट अप करो, कुछ नहीं होता लाइफ में, that's fine. ऐसा ही बोल देते हैं ना? Okay, very good. So initially it is low. Then after that, if the wind speed is 31 to 49 kilometer per hour, मतलब ये और डूब गया, ठीक है? So now you start calling, यार ये तो डिप्रेशन में ही चला गया, बोलते हैं ना? So IMD also calls it as depression. ठीक है? So depression. Then if the speed becomes something like 50 to 62 kilometers per hour, 52, है ना, तो कई बार बोलता है किसी को कि यार इसको डिप्रेस्ड क्यों दिखाई दे रहे हो, राइट? और फिर देन डीप डिप्रेशन. नेक्स्ट इज व्हाट? यार वो तो पक्का डिप्रेशन में चला गया, बोलते हैं ना ऐसा. है ना, वो पक्का डीप डिप्रेशन में चला गया एंड वी मस्ट हेल्प। इस टाइप से टर्म्स हम सुना होगा आप लोगों ने, है ना। सो वो कौन सा विंड स्पीड पे बोलता है। उसके बाद व्हेन द फर्दर विंड स्पीड इंक्रीज, मतलब और लो हो गया, ठीक है, और ही ज्यादा क्या करते हैं, हाँ सॉरी, कोमा में, नहीं नहीं, फिर आप उसको एक नाम दे देते हो, नाम दे देते हैं ना, बोलते हैं यार ये तो बिल्कुल देवदास हो गया। ये सुनो, तो देवदास टाइप का कुछ नाम देना शुरू करते हो, कबीर सिंह देवदास, अर्जुन, क्या है वो, अर्जुन रेड्डी, और भी है दो तीन, बहुत सारा, नहीं अभी वहां तक नहीं पहुंचा है, ठीक है। सो डू यू गेट इट। सो यू स्टार्ट गिविंग नेम्स exactly like this. IMD also start giving names at this time. तो यहां पे आके बोल देता IMD, this is a cyclone. And once it calls it a cyclone, it gives the cyclone a name. जैसा आप नाम दे देते हो, है ना, whatever, उसी तरह से IMD also gives a name at this point. ठीक है, so now it is called as a cyclone and it is given a name. Given a name. Okay, so now it is called a cyclone. Then, if the speed is 89 to 117 kilometers, the IMD starts calling it as a not only cyclone but severe cyclone. क्या बोला था? Severe cyclone. Then, if the speed is 118 to 165, and all of this you have to remember at the time of prelims, they can ask you all this. So, severe cyclone, उसके बाद क्या बोलता है? Very severe cyclone. ठीक है, 118 to 165, सो पहला साइक्लोन, फिर सीवियर साइक्लोन, फिर वेरी सीवियर साइक्लोन, ठीक है। देन 166 टू 220 किलोमीटर, अभी क्या बुलाएगा, एक्सट्रीमली, ठीक है, तो अगला क्या बुलाया, एक्सट्रीमली सीवियर साइक्लोन, मजाक बना रखा है, ठीक है। सो पहले सीवियर साइक्लोन, फिर वेरी सीवियर साइक्लोन, फिर एक्सट्रीमली सीवियर साइक्लोन, एंड देन व्हेन द विंड स्पीड इज मोर देन 200, तो अभी क्या होना चाहिए, हाँ, वेरी एक्सट्रीमली नहीं, नाउ इट कॉल्स इट एज सुपर साइक्लोन। ऐसा बोलता है, मजनू बन गया है तो, ऐसा बोलते हैं ना आप लोग, हाँ इसका तो कहानी आएगा, है ना, मजनू लैला टाइप, यू रीड फॉर जनरेशंस, ठीक है, सो योर जनरेशंस आर टोल्ड अबाउट इट, ठीक है। तो यहां पे भी सुपर साइक्लोन, बिकॉज जनरेशंस लाइक यू हैव बीन टोल्ड अबाउट इट। रिमेंबर सुपर साइक्लोन, बीच में बहुत सारा साइक्लोन आया, यू डोंट रिमेंबर देम, ठीक है। तो ये अर्जुन वॉट एवर एंड कबीर सिंह, इस टाइप का तो बहुत सारा आता रहता है, बट लैला मजनू और हीर रांझा वो एक दो ही होते हैं, राइट। जनरेशंस आर टोल्ड, सेम वेज super cyclones are few. For example, 1999 we had a super cyclone, I hope you remember, right. So that was a super cyclone, right, which you still read about. Why? When do you call a cyclone as a super cyclone? When, देखो ये जितना भी स्टोरी में बीच बीच में बनाता रहता हूं ना, it has a purpose, right. What is the purpose here? To understand at which level you will call it as what, ठीक है, right. So which are the cyclones that we are generally taught about? Super cyclones, the bigger ones. We generally do not go on reading about every cyclone, because every cyclone they just keep coming in the newspaper and going, ठीक है, but only the super cyclones are the most destructive of the cyclones, right. They are the most extreme of the cyclones. Is that okay? ठीक है, so we call it as super cyclone because they are the ones that we remember. All right, good enough. So सारा साइक्लोन स्टोरी समझ में आ गया. So can you give me the breakups जल्दी जल्दी? Yes, सबसे छोटे वाले को क्या बोलते हैं? Low, है ना? Then depression, and then deep depression. And when do you start calling it as a cyclone? What wind speed? 63 kilometer or higher. You start calling it as cyclone, and that's where you start giving it a name. And up to which do you give, up to what up to 220 you keep giving them names and go on calling them as cyclones, severe cyclone, very severe cyclone, एक्सट्रीमली सिवियर, बट वो सारा ब्रेकअप आपको एग्जाम के टाइम में याद रखना है, बिकॉज दे कैन गिव यू ऑल दोज इन योर प्रीलिम्स मैच, ठीक है. एंड देन फाइनली सुपर साइक्लोन एट व्हाट स्पीड, 220 kilometer or more, which are the most destructive, and we don't get super cyclones often. You get them once in a while, once in maybe decades you get. Is that okay? ठीक है, कर लेना पैक यार, मैं कहाँ रोकने वाला हूँ आप लोग को. मतलब इतना जल्दी है, यहाँ से एकदम भाग करके पता नहीं कहाँ जाने वाले हैं. मतलब इतना ही पकड़ा किसी को थोड़ी है, अभी भाग जाओ पहले ही. मतलब दिस काइंड ऑफ बिहेवियर आई डू नॉट अंडरस्टैंड. ये ना मेट्रो स्टेशन पे भी दिखता है, देखा आपने? वो जो सिक्योरिटी वाला होगा ना, वहां तक फुल स्पीड में भागते हुए जाएंगे, उसको क्रॉस करके फिर आराम से, लेकिन वहां तक फुल स्पीड में, एज इफ पता नहीं कोई अगला फ्लाइट पकड़ना हो. फिर मेट्रो के अंदर भागते हुए चढ़ जाएंगे, फिर आराम से बैठ गया. है ना, एज इफ घर के ऊपर पता नहीं आज ही प्रीलिम्स का पेपर कोई पहुंचाने वाला है. तो इतना क्यों रेस लगा रहता है हमेशा लाइफ में? दिस इज दिस इज बिकम आवर जनरल बिहेवियर, राइट. ये हमारा ना नॉर्मल ह्यूमन बिहेवियर हो गया. कुछ भी कहीं पे भी लाइन लगना है तो पहले भाग के पहुंच जाओ. ठीक है, कुछ नहीं होने वाला यार. 2 मिनट लेट भी हो गया तो ऐसा नहीं है कि यूपीएससी एकदम बस लास्ट में 2 मिनट है, पहुंचा नहीं तो कैंसिल. अरे समझ में, तो इसीलिए ऐसा हड़बड़ नहीं दिखाना चाहिए. ओके, कुछ नहीं होगा, और जाना है तो उठो और निकल लो चुपचाप से. हु इज स्टॉपिंग एनीवेयर? ठीक है. So it's not only about class. I'm saying this is a general behavior that we have, and this is generally observable in our part of the world. Population बहुत ज्यादा है ना, हर जगह लगता है यार वहां लाइन लग जाएगा, उसका पहला बस क्रॉस कर जाओ, उसके बाद तो अंदर जाके भले 2 घंटा वेस्ट कर लेंगे, लेकिन वो 2 मिनट वेस्ट अफोर्ड नहीं कर सकते. ओके, कमिंग बैक. देखा, बेकार में एक उस चक्कर में इनको भी लेक्चर लग गया. ठीक है. सो ओके, कमिंग बैक. सो इज दिस क्लियर? पक्का? So next class we start from this and continue. ठीक है. And I do expect you people to learn lot many newer things also from your class. Your behavior should also change. Start becoming more mature. अगर कोई ज़्यादा जल्दी भाग रहा है उसको पहले बोल दो, यार जाइए आप, कोई बात नहीं, मुझे कोई डीएम का ओथ लेने नहीं जाना है. आप जाओ, आपका वेट कर रहा होगा. ठीक है, जब मिलना होगा तो बुला के दिला देंगे. डोंट वरी. ओके, गुड. That's it. Thank you. Next class we start from here. Doubt है? आ जाओ. Sir, anything online you want me to take up? That's it. Thank you, online people.